Hey guys, welcome to yet another tutorial by Scalar. So in this particular tutorial, we're going to see complete machine learning from scratch to most advanced levels. So we'll be looking into demos and hands-ons throughout the session to keep it more interactive and more fun for you guys so that you would not get bored at any point. So now, before we move on with this particular session, please make sure to subscribe to our channel and also leave a like if you enjoy our content. And if you want more of our videos, obviously hit the bell icon and you will get updated every single time we upload one. And if you have any queries, leave a comment down below and we would be addressing all of your questions and helping you out. So now, before we move on, let's look at what will be covered in this particular session, right? So let's start with that. So first we'll be covering how to become a machine learning engineer. So once we understand what is machine learning and how to become a machine learning engineer, then we'll discuss the differences between artificial intelligence and machine learning. Okay, and then we'll be looking into the machine learning roadmap for beginners. So if you're a beginner, make sure to check out this particular video, this particular part of this particular session, so that you would get a better understanding of what to do if you're a beginner in machine learning. And then we'll be looking into certain concepts like tree-based models in ML, linear regression in ML, and how does a recommendation engine work. So these topics we'll be looking into. Once these are done, then we'll be looking into how image processing works. So, okay, image processing for beginners. So if you're a beginner, again, all of these tutorials are simple. You can follow through, you can practice and follow through. And then finally, we'll be looking into three main topics. One would be how to clear a machine learning interview, right? This is a machine learning Facebook interview. So this is a really good and really important part of this particular session. And then we'll be discussing about machine learning and artificial intelligence research papers. So again, here, how to write machine learning and artificial intelligence research papers. These are pretty advanced topics. So as I told you, we'll go from scratch to the most advanced topics. So pick the right part of this particular session, understand and learn whatever you need to. So you can choose any topic in between and learn. If you just want to learn about image processing, check out that part of the video, but everything is available. So you guys can go through the entire tutorial. So now, without any further ado, let's begin with it.
Have you ever been stuck in a situation where you wonder if you have enough skills and potential to break the ice, but soon you realize that the skills you have gained do not align or match up with the employer's expectations? Like you, we all have been into this tiresome loop. But the solution to this is to explore and learn emerging technologies, which is the most painful and tedious task in job searching. With the recent buzz around the machine learning, job seekers are primarily attracted to this exciting field that offers many job opportunities. Still, the confusion about what it is and what they need to learn is always buzzing around. In today's session, we will tell you what works under the hood. Here is everything you need to know to become a machine learning engineer. Before we begin any further, we would like to address today's agenda. First, what is a machine learning engineer? Second, prerequisite to becoming ML engineer. Third, ML engineer career path. Fourth, can you become an ML engineer without a degree? Fifth, ML engineer career scope and salary. So what exactly is a machine learning engineer? A machine learning engineer or an ML engineer is an IT professional who focuses on researching, designing, and building self-running artificial intelligence systems to automate predictive models. In simple words, a machine learning engineer is a sophisticated programmer who builds machines and systems that can perform various tasks and apply adequate knowledge with minimum or no specific commands. An ML engineer bridges data scientists, administrators, data analysts, data engineers, and data architects. Now, when you have got your answers to what a machine learning engineer is, it's time for us to introduce you to the prerequisite to become one. This session will help you explore the required skills to avoid falling into an unnecessary trap. Let us understand what kind of different skills you need to ace this area of working. The first and foremost skill is the programming skills that every ML engineer needs to be a master of. Computer science fundamentals are vital for machine learning engineers as they pave the way for a successful and fruitful career. These fundamentals include data structure algorithms, computability, complexity, and lastly, computer architecture that you should adopt and implement effectively when programming. There are specific ways to hone and develop the programming skills, such as participating in various competitions and practicing problems regularly. That will be a building block of your career. Another essential step that will put you ahead of your competitors is learning programming skills. As an ML engineer, you must be familiar with various programming languages, including R language, Python, Java programming, etc. R is explicitly used to develop statistical software and data analysis, whereas Python lets you create and analyze piles of data without much chaos. Now, when you're well aware of the programming skills, it's time to move further and introduce you to another important skill: data modeling and evaluation. Understanding data modeling and evaluation is necessary as it acts as a base for your career as an ML engineer. Before learning more about the skills, let us quickly discuss data modeling briefly. What is data modeling? Data modeling is the process of estimating the underlying structure of a given data sheet to find functional patterns that are not obvious to the naked eye. Remember, it is one of the most complex steps in any machine learning project, as each data set is different and highly specific towards the project. Coming back to the point, as an ML engineer, you should be well versed with data modeling and evaluation. After all, the data is your bread and butter. Along with acquiring proper instances about data modeling, you need to evaluate the data using a suitable algorithm for the data. Applying machine learning algorithms and libraries is another essential skill you cannot afford to skip if you are an aspiring ML engineer. It is necessary to be well aware of the common machine learning algorithms to know where to apply what algorithm. Standard implementation of machine learning algorithms are widely available through libraries, packages, and APIs. Two of the most popular examples are TensorFlow and scikit-learning. Therefore, these are the common types of ML algorithms, namely supervised, unsupervised, and reinforcement machine learning algorithms. Remember, you need to build a sound knowledge of all these algorithms, potential advantages and disadvantages of various approaches. Just go through all the basics of machine learning, such as how biases and variances works, overfitting and underfitting work that will play a commendable role in your journey. In addition to the hard skills we mentioned earlier, soft skills are what sets influential engineers apart. While hard skills are the core of any technical job, soft skills allow you to stand out in the herd. Though we won't be elaborating on each skills here, their names are enough to make an impact. First, communication skills. Second, problem solving skills. Third, domain knowledge. Fourth, time management. Fifth, teamwork. Sixth, adaptability. Seventh, thirst of learning. Knowledge of tools and concepts. In addition to a solid understanding of various programming fundamentals and languages, every machine learning engineer should acquire a considerable amount of proficient knowledge of the following tools and concepts. Let's see what we have stored for you all in here. TensorFlow. TensorFlow is an end-to-end open source platform for machine learning whose APIs are arranged hierarchically with the high levels APIs built on the top with the lower ones on the lower level. This system manages the different aspects of machine learning. However, it uses only a particular TensorFlow API to develop and train machine learning models. Machine learning developers generally use low-level APIs to create and explore new algorithms. Second, Spark and Hadoop. Developed by the Apache Software Foundation, Spark and Hadoop are widely used frameworks by machine learning engineers for significant data architecture. This framework is highly effective and cost-friendly that contains an extensive ecosystem of open source technologies that manage and process huge chunks of data. Apache Kafka. The Apache Kafka is a popular open source distributed platform that has helped thousands of stable companies with high performance data pipelines, data integration, streaming analytics, and mission critical applications. This platform is written in two trendy programming languages, Scala and Java, aiming to provide a highly throughput platform for handling real-time data feeds. Weka. Weka is a unique platform written in Java, a collection of machine learning algorithms for solving the complex issues of real-world data mining. It is suitable to run Weka on almost all platforms. Its most popular features are machine learning, regression, experiments, data mining, clustering, workflow, pre-processing, association rules, visualization, classification, and attributes selection. Matlab. Matlab is a high-performance language typically used for mathematics and computation, algorithm development, modeling, simulation, prototyping, data analysis, exploration, and visualization. This allows machine learning developers to solve various technical computing problems in a fraction of time. Amazon Machine Learning. Amazon Machine Learning is an Amazon Web Services product that allows a machine learning developer to discover and discuss various patterns that boost your team productivity. These are some of the most popular machine learning tools and concepts essential for every machine learning engineer. Now, when you're well aware of the various tools and skills, let's analyze the different career paths that can be formed using these skill sets. Machine learning career path. As mentioned earlier, machine learning is unquestionably a popular choice among youngsters as it maximizes human efficiency while reducing tons of loads. It enables machines to perform and to learn themselves without any command. How cool is that, right? Well, it is. And the career paths it offers are even more exciting. So starting with one of the most completing career choices as a machine learner, machine learning engineer. Machine learning engineers aren't our regular engineers. They transform machines almost into humans through various machine learning experiments using the most popular programming languages such as Python, Scala, Java, etc. Another popular career choice among machine learners is data scientist. This is one of the most popular choice among youngsters to the extent that recently an article reviewed by Harvard Business called Data Scientist the sexiest job of the 21st century. Remember, to be a data scientist, machine learning plays an essential role, followed by data mining to place you on the top. Yet, another popular career choice that machine learning engineers are no longer scared of is natural language processing or NLP. An NLP scientist creates patterns that enable machines to talk to humans in their language. So, the next time an NLP scientist wants to talk to his friend about his breakup, talk with your machine. So, these are some of the most preferred career choices that machine learning engineers consider. Apart from these, you can go for business intelligence developer or human-centered machine learning designer options that will eventually let you write your success story. But wait, what if you don't have a degree? Oh, you must be in turmoil. Well, like all others, you must be thinking that you may need a degree to become a machine learning engineer. But you may skip the degree as well and still be a compelling engineer, if not better. Want to know how? Let's unveil the secret to you. A machine learning engineer degree is always a plus point to give you the push, intelligence, and guarantee to chase success. But if you ask us, degrees are overrated? Degrees are overrated. Taking on and completing a full-blown formal degree is a big undertaking where you blindly invest yourself without analyzing the circumstances and repercussions. Today, we will discuss a few points that will change your mindset and you will agree with the concept of skipping the degree. Most of you will disagree that you still have enormous opportunities to get what you want even if you don't have a degree. You have multiple paths available. Just wear your binoculars, spot the possibilities and seal them. Learn machine learning properly. So to step into the IT world, it's essential to attain a certain level of expertise acquired through formal training in machine learning at home. Yes, you heard us right. There's no need to pack your bags, spending lots of money and wasting years to get a piece of paper popularly known as a degree. First, complete a full-blown online machine learning course. Invest your time understanding lectures, complete the tasks timely and interact to achieve goals. Second, make machine learning books your best friends. Read word to word, understand and make notes. Third, what better than designing your course? Pick a subject of your interest, develop a compelling course that imparts knowledge and add the formalities you require. Let's discuss the scope and salary of a machine learning engineer. Before learning about the career scope as a machine learning engineer, Let's roll our eyes at the 2019 Indeed report that clearly states that machine learning engineering is the best job in the US and India at the moment and for the coming years. What's more interesting is the numbers stating the average salary of an ML engineer in India. INR 689,460 annually. In contrast, the average salary of an ML engineer in the US is $112,448, which is much higher than most reputable jobs available. Let's end our today's agenda with ML engineering career scope. The fact that the world's biggest companies such as Apple, Uber, Microsoft, Facebook, Salesforce, and so on are constantly hunting for ML engineers proves the number of opportunities exponentially growing. So, if you are planning to take baby steps, we urge you to go for it, as you will be trending when you are a machine learning engineer. Scalar has launched an exclusive data science program which was created based on insights from 100 data scientists working at 50 top tech companies. The program helps you tackle the toughest problems in data science and machine learning. Experience live classes from data scientists, mentorship from top industry experts, and work hands-on with 40 plus critical tech tools to solve for real-world business problems. Know more about the program by clicking on the link in the description below.
Hi everyone, welcome to another video by Scalar where we are going to discuss and differentiate between artificial intelligence and machine learning. Today's discussion is going to be very interesting as we will discuss the career path of both areas and how they are different and how you can excel in any career regardless of which one you pick. When building a career in data science, it must get really intimidating to judge which road will assure you success. Are you a person having thoughts like what is the difference between AI and ML? Or simply someone thinking about which career option to go for and how to pursue a particular path? Don't worry, we are here to guide you through it all. In this particular session, we will first learn about AI and how it is different from ML, the different roadmaps we need to follow, and the scope in the both fields. We will also cover salary and job outlooks for the two. We acknowledge that making a career choice is a lifetime decision, and thus we try to impart most knowledge from this video that we can. But before we get started, please take some time out and subscribe to our channel. Also press the bell icon so you never miss an update from our end. So without wasting more time, let's get right into it. Curious what makes machine learning different from AI? In this digital era of self-driving cars and intelligent robots, AI and ML have created more hypes than ever. They are continuously empowering new technologies to improve systems like medical diagnosis and other important areas. But what is making the two different? In simple words, machine learning is a small part of AI. So machine learning can be AI, but not all AI can be machine learning. AI is the biggest, all-inclusive factor containing a smaller subset like machine learning, deep learning, and neural networks. AI provides the machine feature that mimics human intelligence. On the other hand, machine learning practically implements human-like information processes. So one can say that without ML, AI can be a tricky pony even when performing a single superhuman task. Want an interesting example of AI? Do you remember how AI showed the power of technology only by defeating champions at games like chess in the early days? Today, after multiple advancements, AI can now employ face, speech and picture recognition, including translation. In fact, nowadays, AI has incorporated more human-like components like Alexa and Siri to connect to human emotion and interpret tones. However, when talking about machine learning, it is how Alexa and Siri can acquire their diverse functionalities. With the help of machine learning, AI can perform more than a single task to interpret data into patterns and make predictions like recommendation in song apps, as well as movies and videos on Netflix and YouTube. Now let's get into more details about AI and ML. What is artificial intelligence? Artificial intelligence is a comprehensive phrase that describes the process and software that impersonates human intelligence. It covers a vast range of studies including computer vision, machine learning, natural language processing, autonomous system, and robotics. With the use of AI, machine can identify patterns, solve problems, and provide insights to businesses and humans. According to top evangelists, it is quite difficult to overstate the impact and reach of AI in the next decade. It is a dynamic field that can be directly compared to the rate of transformation of electricity from the late 1800s till now. Remember, AI's impact will be even greater than the world has ever seen. Artificial intelligence covers the computational aspect of the term. Also, since we do not define machine reasoning outside the concept of human behavior and thinking, we can say AI and human intelligence are directly linked. Now let's talk about what is machine learning. Machine learning, on the other hand, is a part of AI. In other words, where AI is overall the definition of being smart, ML is from where a machine is extracting data, learning about things that would be difficult for a human. Machine learning has the capability to go beyond human intelligence. It is primarily used for big data in a short period using algorithms to be a better process. For example, a manufacturing plant collects information from the machine and sensors present on its network in unit to go far beyond human normally can process. The system then accesses patterns and identifies anomalies that indicates the problem human can address. Here are a few points to help you differentiate between AI and machine learning in terms of skills required. Now that you know that both are two different concepts, you must work on your skill sets as required by the given field for a brighter career. Are you eager to know the skills that you can add to your resume? Because AI is a term that encompasses various aspects of smart technologies, the skill set required is more theoretical than technical. On the contrary, aspiring candidates looking forward to machine learning as their career must have a high level of technical expertise. Skills required for AI. Students pursuing career in AI must have a strong hold on data science, algorithm and techniques for proper analysis, robotics, machine learning and how to draw conclusion, Java programming, data mining, programming design, problem solving, ethical standards in developing AI system. Skills required in machine learning. Students pursuing machine learning must have a strong hold in physics, neural network architectures, applied mathematics, natural language processing, algorithms, data modeling and evaluation, probability and statistics, data modeling and evaluation. When discussing career paths, the decision becomes even clearer when you know the job role you have to play in the field. If you want to know about the responsibilities you will be interested with, stay with us. We are going to state some career opportunities you can opt in artificial intelligence field. AI job opportunities have been on an upswing for the past decade. If you think you have a driven mind and are fond of transforming and improving the existing system, you are the best fit for an AI job. The good news is that as the world is advancing, the scope for AI related job is increasing more than ever. However, to understand whether you want to proceed in this career path or not, let us discuss some job roles, shall we? AI developer. The key responsibility of AI developer are to carry statistical analysis, test, design and develop machine learning programs. In addition, the professional is also entrusted with implementing a well-performing algorithm, deep learning system and training ML system containing a perfect data set. Programming skills required for this are Python, Java and Scala. Frameworks required are scikit-learn, Apache Hadoop, Azure, Spark MLib, Amazon Machine Learning, Apache Signa, H2O, ML Studio. Next up, data scientist. A data scientist finds valuable data sources and streams to work with data engineers to automate data collection processes. In addition, they carry huge data analysis to recognize patterns and trends to build predictive models and stats. This in turn helps the company to propose a solution, build a strategy and create a comprehensive ML system using visualization techniques and tools. Programming skills required are R, Scala, SQL, Python, SSAS, SAS. Framework required are Apache Hadoop, Azure, Spark MLib. Next role we have is data science lead. The job role of data science team lead is to provide direction and manage resources. The position of a data science lead requires high level of knowledge in the field of machine learning architectures, big data systems, data science technique, machine learning architectures, and interpersonal skills. It is task of analytical manager to set priorities for analytics and data science team to elaborate on finding of the senior management. Programming tools required are Tableau, SQL, Excel, Python, R, and Power BI. Soft skills required are strong management and interpersonal skills. Next up, we have research scientist. Suppose you are looking for pursuing a career as a research scientist. In that case, you are expected to have mastery in multiple AI disciplines like computational statistics, mathematics, deep learning, and machine learning. Similar to the case of data scientist, a research scientist too is expected to hold an advanced or doctoral level of degree in computer science. Programming skills required are R, Python, Scala, SSAS, SAS. Frameworks required are Hadoop, Apache Signa, Azure, ML Studio. Career opportunities you can opt in machine learning field. Machine learning has been one of the most popular career paths since its boom recently. In fact, it was even ranked as the best job to have in the year 2019 according to some research. It is mainly because of the work significantly reduces human effort and improves the machine's performance by enabling them to learn things by themselves. The job roles you can choose for yourself including machine learning engineering, MPL scientist, business intelligence developer, data scientist, and human-centered machine learning designers. Let's begin with machine learning engineer. As the name suggests, the machine learning engineer is entrusted with running machines, learning experiments using programming skills like Java, Python, Scala, and others. Moreover, when recruiting, the company usually looks at how well the candidate is accustomed to the data modeling, programming, statistics, probability, system design, and machine learning. Machine learning professionals also have to analyze data to develop effective algorithms that run autonomously without or with minimum human intervention. Programming languages required are Python, Scala, Java, C++, and R. Skills required are data modeling, system designs, software architecture, data structures, ML algorithms. NPL scientists. Not many have heard of NPL scientists. You may not have too. So let us clear the concept to you. NPL stands for Natural Language Processing, which involves enabling the machine to understand human language. In other words, the machine will be able to talk to human in their own language. It is just how Alexa talks to you. So, the primary job of NPL scientists is to create a machine that contains patterns of speech and can translate spoken words into different languages. Thus, this position requires syntax, grammar, and spelling fluency of at least one language apart from machine learning. As a result, it helps in imparting the same skill to the machine. Applications, Duolingo and Grammarly. Skills required are basic level ML skills, syntax, grammar, and spelling fluency in one or more languages. Next up, we have Business Intelligence Developer. A business intelligence developer is entrusted with machine learning and data analytics to analyze, collect, and interpret large chunk of data. As a result, come up with actionable insights used to make business decisions by company executives. To be clear, they use data to make a business decision better. The company identifies a professional to be an efficient business intelligence developer when they hold knowledge of multidimensional and relational databases. Also, the candidates must be well versed in Python, SQL, Scala, Perl, etc. In addition, if you have knowledge of Power BI, that would be cherry on the top. Programming languages required are Python, Scala, SQL, Perl. Moving on to data scientist. Did you know that according to Harvard Business article, a data scientist is acknowledged as the sexiest job of the 21st century? A data scientist makes use of an advanced analytical tools inclusive of predictive modeling and machine learning. As a result, able to accommodate, analyze and interpret large chunk of data and build productive actionable insights. Further, businesses use it to make an important decision regarding operation. So apart from having a machine learning skills, a data scientist must also hold knowledge of statistical research techniques, data mining and other big platforms. Moreover, if you are trying for the job role, programming languages you need to know: Python, Perl, SQL, Scala, R, SAS. Framework required are Pig, Hive, Hadoop, Flume and Spark. Moving on to human-centered machine learning designer. The human-centered machine learning designer job involves working on machine learning algorithms centered around the human world. It is because of this job role you get the most appropriate movie suggestion on Netflix. This type of designer develops various softwares that can perform human-centered tasks based on patterns and processings. It allows the machine to know the user's preferences without the help of cumbersome program for every scenario. Programming skills required are ML concepts, algorithms, statistics and mathematics. Now that you are clear on the job role of both career paths, you must be clear about your decision. However, do not forget the job scope and salary structure aspect of the field. If interested, stay connected. Know how much salary you can expect from the field and their scope. AI engineering has the most lucrative job path you can find in the world. Fortunately, it has been growing at a great pace. In fact, the average entry-level salary you can expect to get in India is around 8 lakhs. Moreover, as you proceed to the higher levels, the salary can extend up to 50 lakhs. ML engineering jobs, on the other hand, does not stay behind. There are also abundant job opportunities available in this particular field. The average salary that you can expect in India amounts to 6 lakhs, whereas it can go up to even 70 lakhs per year. To sum it up, till now we have discussed different tasks artificial intelligence and machine learning aspects can deal with. We now know that machine learning is only a subset of AI which works on macro level. Next, we pointed out the skill sets every candidate should necessarily gain according to their field of interest. Additionally, we also learned about job profile and salary we can expect from two paths. Scalar has launched an exclusive data science program which was created based on insights from 100 data scientists working at 50 top tech companies. The program helps you tackle the toughest problems in data science and machine learning. Experience live classes from data scientists, mentorship from top industry experts, and work hands-on with 40 plus critical tech tools to solve for real-world business problems. Know more about the program by clicking on the link in the description below. We hope you find yourself with all the necessary details that you would need to make an important career choice with this video. If you found this video helpful, do not forget to like this video. Also motivate us to come up with more such videos for you by subscribing to our channel and sharing it with others. Thank you so much for sticking by. See you next time. Bye.
With the significant amount of resources these days, it is not at all surprising that if a person gets confused on how to start or maybe even build a career in machine learning. So in this video, we'll be talking about how exactly can a person start his or her career in machine learning, what are the important skills that will give you that boost to secure a job in the field of ML, and what are some of the most average salary trends in this field. So without further delay, let us get right into it. Let us first understand what ML is. Machine learning can be defined as the science of making computers learn automatically. With machine learning, the computers can make decisions and predict outcomes without any human intervention. The whole process is achieved using algorithms which play an important role in building machine learning models, which can then be applied to a variety of other applications. Keeping in mind the definition of machine learning, now let us look at what are some of the most useful skills that one can learn to land a job role in machine learning. Firstly, mathematics and statistics are an integral part of machine learning. That being said, not all the mathematical concepts are relevant to ML. Some of the most important ones that are in fact relevant to ML are linear algebra, probability distributions, and calculus. One reason as to why maths is a prerequisite for ML is that mathematics is essential for applying the algorithms correctly and testing different hypotheses. With the knowledge of maths and statistics, one can pick up intuitions and learn the ML techniques really fast and accurately. Adding one or two programming languages to your portfolio is a great way to build foundations in machine learning. There are different programming languages in the current scenario, but the most suitable ones for machine learning are Python and R. The fact that Python is a high-level language makes it easy to understand and implement. An added advantage is that Python is so popular in today's world, so you'll have answers to almost every question related to Python on the internet, because the community is that vast. R is a low-level language which does the same thing that Python does, but most of the time it is used for data analysis and exploratory work. Having ML knowledge is another key aspect in building a career in machine learning. This includes both machine learning libraries and algorithms. For example, the Python machine learning libraries are the most preferred libraries used for machine learning. They deal with anything and everything related to machine learning. Libraries are basically a set of useful functions that get rid of writing the code from scratch. This in turn helps to reduce code redundancy and saves so much time. Some of the most commonly used machine learning libraries in Python include NumPy, which is used for various math operations involving multi-dimensional arrays and matrices, Pandas, which is mainly used for data analysis, importing data from various file formats like CSV, JSON, XML, and Excel, Matplotlib, which is mainly used for data visualization and involves plotting 2D graphs of arrays, SciPy, which is used for solving scientific and mathematical problems and is built on the NumPy extension, Scikit-learn, which provides efficient tools for machine learning such as regression and classification, and lastly, Keras, which has a wide collection of deep learning models. After gaining some knowledge on machine learning libraries, it is now important to focus on some machine learning algorithms and how they work. Each algorithm has its own purpose, like for example, linear regression is used to find out the relationship between variables and predicting certain values. If you want to dive deeper into machine learning algorithms and how they are used, there are tutorial videos for which you can find the links in the description box down below. After learning all these above skills, one must put them to use by creating small projects and maybe even contributing to open source projects on GitHub. This not only improves a person's practical knowledge, but will also give a slight advantage over people who don't have projects or any contributions. Apart from these two reasons, it is a good way to showcase one's skills. Now that we've talked about how one can start a career in machine learning, let us discuss the average salary trends and some common job roles in the field of machine learning. A machine learning engineer is someone who develops programs and algorithms that hugely enable machines to act upon by themselves. A typical machine learning engineer in India earns about 7,60,000 rupees per annum, whereas the same job in the US will fetch you around 147,807 US dollars per annum. A data scientist designs algorithms and prediction models to mainly analyze the data. The average base salary for a data scientist in India is about 9 lakhs, and in the US it is 119,000 USD in a year. Principal scientist is someone who does research and comes up with innovative and impact-driven machine learning projects. The job role also involves coordinating with stakeholders and other teams. This is one of the most high-paying jobs in machine learning, and it will fetch you around 15 lakhs per annum in India and 141,000 USD per annum in the US. A data engineer is a person who is responsible for data cleaning and making it readily available for further machine learning processes. This is one of the most important jobs in machine learning due to the fact that without proper data, it is impossible to get best predictions and insights. On an average, the mean base salary of a data engineer in India is about 10 lakhs, and this amount is around $125,000 in the US. The salaries in this field hugely depend on the experience level, your skills, location, and the organization you're working for. Various skills like deep learning, artificial intelligence, data analytics, natural language processing can help you stand out since these are especially in demand. And the jobs including these skills will fetch you a lucrative salary as well. With that, we have reached the end of this video. Keeping in mind all the skills that we have discussed today, it will help you start your career in machine learning and most probably land that dream job of yours. If you have any questions related to machine learning roadmap, let us know in the comment section down below. We will be more than happy to answer them.
Hello everyone and welcome back to Scalar's YouTube channel. In today's session, we will learn about machine learning and tree-based model in machine learning. If you are interested in learning more about this revolutionary technology, keep watching this video. People who come from technical backgrounds might have heard about tree-based models, machine learning or AI. What are these? What is machine learning? With tree-based models. If you want the answer to these questions, stick with us till the end of this video as we are here to clear all your doubts. Today, we will tell you what happens under the hood. But before we discuss this any further, make sure you subscribe to our channel and keep receiving all the updates. Hit the bell icon to never miss an insightful update from us. Without further ado, let's quickly move to today's agenda to understand what we will cover in today's session. Let's get started. We will follow top to bottom approach and start with the basics. What are tree-based models? The significance of a decision tree, what exactly is a random forest, what is bagging and what is boosting. We hope the agenda is clear. Now it's time to dive into the actual discussion. Without wasting any more time, let's start with our first topic. What are tree-based models? If you look around carefully, you will see there are millions and millions of machine learning examples that you deal with daily without noticing them because you are so used to them. Some of the most common examples of machine learning are the face detection algorithm or Netflix recommendations. In today's digital era, machine learning is applied almost everywhere. Tree-based classification models are exceptionally important in the world of supervised machine learning algorithms, which are also one of the type of machine learning. What makes these tree-based models extra special is that they can be used for both classification and regression, unlike other machine learning algorithms. Since our main area of discussion is in the decision tree, let's directly jump to the gist of today's video. Before discussing the decision tree, let us tell you why we choose decision tree on the very first go. The decision tree is one of the most important yet easy machine learning algorithms which belongs to one of the few interpretable models where you can understand why decision is being made. Now that you have backstory, let's take you through decision tree in detail. What is a decision tree? In technical terms, a decision tree is a graphical representation of multiple possible solutions to a decision based on a particular condition. After learning the definition, you might wonder why this algorithm is called a decision tree. Well, we have the answer. The machine learning algorithm is known as the decision tree because it starts with the root and the branches are all possible solutions, just like a tree starts from a root and has multiple branches. We believe most of you have used the decision tree algorithm but never understood it in real life. Let's understand how. Remember, when you dial a toll-free number, it directs you to intelligent computerized assistant who asks you to dial 1 for a specific option, 2 for a particular reason and so on. The moment you start following their instructions, it directs you to another voice repeating the process. This goes on until you reach the right person who gives you a reliable solution. You might think you are trapped, but it's actually a decision tree where the company tries to resolve your problems through a well-defined structure. Let us now understand the decision tree with another example. Imagine you want to go out swimming this evening. What would be your first step? You will probably check how the weather is. Is it sunny? If not, when will it rain? If not, is the weather suitable for swimming? Now, that's exactly what a decision tree is, where you are bound to answer all possible questions to reach a reliable answer. With a clear understanding of the decision tree, it's time to move further and understand the next tree-based model in machine learning, the random forest. So what exactly is a random forest? Let's understand here. What is a random forest? One of the most used and popular supervised machine learning algorithms is random forest, used majorly in classification and regression. As the name suggests, the machine learning algorithm randomly creates a forest using multiple trees, so the higher number of trees, the better the accuracy. In simpler words, we can say a random forest is a mix of multiple decision trees known as forests. They are glued together to achieve reliable solution or predictions. Note, like most machine learning algorithms, the random forest algorithm is applied to a number of industries including e-commerce and banking, where consumer behavior plays a major role. This algorithm helps get accurate predictions. The random forest trees mostly establish decisions based on human behavior prediction. Therefore, the more the trees, the more accurate the prediction will be. One of the major advantages of random forest algorithm being widely preferred is that it eradicates the limitation of another tree-based model, which is the decision tree algorithm in machine learning. Unlike other models, it minimizes the overloading of data sets, which increases precision and delivers accurate results. Let's understand the decision tree via example. Say a training data set consists of different fruits, including apples, bananas, and oranges. This data set is further classified into subsets given to each decision tree in the random forest, as a random forest is a group of various decision trees. One predicts tree 1 and tree 2 have apples, and another decision tree has oranges as the outcome. After the final voting, the one holding the majority wins. Since we have a clear idea of what decision trees are, what their significance of random forest is, it's time we move our next step and discuss our next topic, bragging or bootstrap aggregating. Have any of you heard of the word bragging? If you already know something about machine learning algorithms and tree-based models, you must also know it. Without further ado, let's look at it closely. What exactly is bragging? Bootstrap aggregation, popularly known as bragging, is a machine learning algorithm primarily designed to improve the condition of variance within a noisy dataset. It promotes the stability and accuracy of machine learning algorithms used in regression and classification. It is believed that the random forest model, which we discussed, is an extension of bootstrap aggregation model responsible for accurate prediction. Leo Breman introduced bagging algorithm in 1996, and since then it has been with us, decluttering our lives. This popular machine learning algorithm is used widely in an array of industry including healthcare, IT, finance, environment, etc., which automates critical tasks and minimizes the risk prevailing in the particular industry. With this, we come to today's last topic, boosting in machine learning. It is one of the most useful machine learning algorithms in data science competitions, as winners agree that the boosting algorithm improves the accuracy and precision of their models. As the name suggests, boosting gives power to a weaker learner and converts them into a strong learner. If you want us to tell you more about boosting algorithms or how they work, we request you to take the pause from this video and subscribe to our channel. Also hit that like button if you truly loved it. Let's discuss today's last topic called boosting algorithms in machine learning. What is boosting? We live in a digital world where we produce an immeasurable amount of data every day. Don't you think there is an urgent need to develop more advanced and complex machine learning techniques that separate your data and store it properly without issues? Luckily, we have the boosting learning techniques that exactly solve our data storing problems. Before we discuss boosting in machine learning, we draw your attention to why it is needed. Why was boosting in machine learning introduced? Let's understand. Boosting machine learning is another highly popular and widely used machine learning algorithm which can be used to solve complex data-driven real-world problems that arises in different industries starting from banking to IT and e-commerce. Let's understand this via an example. Imagine you are given a data set that contains a certain set of images about cats and dogs. You are asked to build a machine learning model considering this data set like others who might want to identify the image using certain rules application to dogs and cats. These rules can be the image with wider mouth means it's a dog, the image with pointy ears might indicate it's a cat, or the image with sharp claws might be a cat. If a single rule is applied individually to all the images, there are higher chances of not getting accurate results. Therefore, it is important to apply different rules to predict the output. These rules reapply to identify whether it's a cat or a dog are called weak learners, as these rules cannot define a cat or a dog individually. This is because you cannot take only one feature to classify and make the final prediction. For accuracy, these predictions from weak learner are combined with each other using majority rules known as the strong learner model. Now we have 3 weak learners, out of which 2 state it's a cat and 1 states it's a dog. Therefore, our final result is it's a cat. Note, the majority always wins. Boosting is one of the most preferred algorithms used to increase the accuracy of the model. Boosting is an effective method to extend the world's famous competitions considering boosting algorithms to implement boosting and bagging to arrive at a reliable solution. In simple words, boosting generates multiple weak learners and combines all predictions to arrive at a strong rule. With this, we come to the end of our topic, the tree-based model in machine learning. We hope now you understand the various tree-based models, specifically those explained in this session. We would love to hear your views about machine learning, tree-based models such as random forest, bagging, decision tree, etc. in the comment section below. Also, if you have any questions about the topic we discussed in this video, you can leave them in the comment section below and we will be more than happy to answer them. Before leaving, let's quickly summarize our discussion. We started our today's session with a brief introduction to machine learning, the most powerful technology in today's time. We began by discussing the tree-based model in machine learning and what those are. In the next step, we learned the significance of the decision tree, one of the most important and widely used machine learning algorithms. As we move further, we discuss random forests, what they are and their advantages. Later, we discuss the 2 most important machine learning models, bagging and boosting. We ended today's conversation with a simple and clear definition of boosting. If you like this video, don't forget to press the like button, share it with your friends and family and subscribe to our channel to show some love and support. Don't forget to press the bell icon to receive notifications every time we upload a new video so you don't miss out on an insightful update. We will see you next time with another insightful video.
Linear regression is one of the most popular and widely used machine learning algorithms. Understanding the importance of linear regression, in this video we'll properly understand what exactly is linear regression and then have a demo with both R and Python languages. So before we start off with the main part, I'd request you folks to like this video and also hit the subscribe button. So on that note, let's start off with the main topic. So we'll start off by understanding what exactly is a linear line. Now, in your high school, you might have worked with this chapter on straight lines. So what exactly is a straight line? Well, it looks something like this, what you see on the screen, isn't it? And now, a straight line also has an equation. So it has a mathematical equation and you can represent that using y is equal to mx plus c. So here, what is y, what is x, what is m, and what is c? Let's understand that properly. Y over here is known as the Y-intercept. Now, what exactly is Y-intercept? Well, so if you put the value of x to be equal to 0, the value which you get is known as the Y-intercept. Or in other words, it is basically that particular value where this line, this blue colored line which you see, that particular point on the y-axis where this line intersects it. Now, we have x. What exactly is that? That is known as the x-intercept. So what is x-intercept? Well, it is that point in your coordinate plane where the line intersects the x-axis. So we know what is y-intercept, we know what is x-intercept. Now what is m? M is the slope of the line. And the slope of the line is measured with the x-axis. So again, in your high school, you would have learned about these different trigonometric functions, isn't it? You would have heard about the angle of sine, the angle of cos, and the angle of tan. So if you want to measure the slope of this line, it is basically the tan value or tan theta value. So what is tan theta? It is opposite upon adjacent, or change in y upon change in x. That will give you the slope of this line. So this is just the introductory match of a linear line. Now, why is this important? Well, this is important because your linear regression model is based on top of a linear line. So here, when we talk about linear regression, this is a predictive model which is based or built on top of the linear line. And we already know that in our linear line, the equation is y is equal to mx plus c. So here, let's actually call this y variable as the dependent variable and this x variable as the independent variable. And I'll give you guys an example to understand this properly. So let's say I'd want to understand the price of a house, or I'd want to predict the price of a house. Now I'd want to do this on the basis of another variable, which is the square feet of the house. So let's say if it's around 1000 square feet, I'm looking to buy 1000 square feet and I'd want a standard price for it in a particular area. So currently I live in Bangalore, and let's say there's this place called as Koramangala in Bangalore, and if I'd want to buy a property of around 1000 square foot, then what should be the standard price of the house in this particular area? So for that purpose, what I can do is I can go ahead and build a linear regression model. And over here, the price of the house would be the dependent variable, and I'll denote it with y, and the independent variable or the predictor is the square feet of the house. Now, we are calling these dependent and independent variables because the price of the house is dependent on the square feet of the house. So let's say if I tell someone that the property is of around 2000 square feet, then I'd want them to tell me what is the standard price of the house. Similarly, if I tell them it is around 5000 square feet, what would be the price of the house? So here x, which you see, x is the independent variable, and in this particular example, x would be square feet of the house and y would be the price of the house. So this is how we are using this equation of a straight line to predict something. And also when it comes to linear regression, you'd have to remember that the value which you are predicting or your output or your dependent variable has to be numerical in nature. Now, why is it? Because this is a straight line, obviously. And when you say y is equal to mx plus c, y has to be a numeric value. So this was one such example where we could use linear regression. And now, what we saw was actually the simplest version of linear regression, and obviously it is called a simple linear regression. Now, instead of just one variable, let's say, if we take the same example, if I want to predict the price of the house with respect to, let's say, the square feet of the house, and also I'll add another factor into the picture, and that would be the number of rooms. Now, let's say what I'd want to do is I'd want to predict the price of the house on the basis of the square feet of the house and number of rooms. So here I'm denoting x1 with square feet of the house, and the number of rooms over here, that will be x2. Now what we'll get is a plane. So consider this to be a three-dimensional feature space. In that three-dimensional feature space, obviously you'll have y is what you're trying to predict, x1 and x2. Now, instead of x1 and x2, you can just call that x and z. So in your three-dimensional feature space, you have x1, x2, y. Or if you want to make it easier, or if you want to understand these terms properly, consider this is a x, y, z coordinate plane where x and z are your predictors, or x1, x2 are your predictors, and y is what you are trying to predict or the result. So this is how, when you have more dimensions, when you keep on adding more dimensions, so right now what we have is a linear plane. Now that can be extended to hyperplanes. So this is how linear regression works when you're adding multiple variables into the picture. So this was the theoretical aspect of it. So for now, if it is seeming too complicated, just understand that in linear regression, what you're basically doing is trying to understand the relationship between the independent variable and you also have the dependent variable. And as the independent variable changes, you're trying to understand how the dependent variable also changes. Now that we've understood this, let's go ahead and implement a demo in RStudio on the Boston housing dataset. Right guys, so I opened up RStudio over here. Now, my first task would be to load up the Boston dataset, and this Boston dataset is, it's pre-installed in RStudio. And it comes inside a library. So we have a library called as mass. So if we have to load a library, I'll just write down library. Inside this, I'll give the name of it. I'll just write down mass again. Now that I have loaded this library, I can just have a glance at the dataset. So I'll write down view, and the name of the dataset is Boston. So now let's understand this dataset properly. So I'll give in a question mark over here. Let me write that question mark properly. Let me feed in Boston and let's see what do I get. So this is housing values in suburbs of Boston. So I've got details about the different houses which are present in the suburbs of Boston. And with this demo, what I'd want to do is I'd want to predict the median price range of these houses in Boston with respect to various factors. So all of these columns which you see, these are the factors on the basis of which I am trying to predict this last column. This last column which you see is MEDV. So here if you see MEDV, let me also zoom this a bit. Right. So MEDV, here you see that this is the median value of owner occupied homes in $1,000. Now we've got all of the different columns over there. So we've got CRIM, which would stand for per capita crime rate by town. After that, we've got ZN, which is proportion of residential land zones for lots over 25,000 square feet. Then INDEX, which is proportion of non-retail businesses acres per town. We've got NOx, which is nitrogen oxides concentration parts per million, RMS, average number of rooms per dwelling. Then we've got age, which is proportion of owner occupied units built prior to 1940. So all of these are the different columns which I have, and on the base of all of these columns, I'd want to predict the price of the house. Now, before I do that, let me start off by doing a bit of exploratory data analysis. So let me just close this for now. So I've had a glance at this data set. What I'd want to do is all of these individual columns which are present, I'd want to analyze them a bit. So for that purpose, what I'll do is I'll again load up a new library called as ggplot2. And with the help of this library, I can perform beautiful visualization. So let's say I'd want to create a histogram for this column called as CRIM. I'll just write down ggplot, and then I need to map something on the data layer. So here, data is basically the data set on which I'm working on. And the data set is Boston. So let me just write down Boston over here. And AES is the aesthetic. So from this data layer, I need to map something onto the X aesthetic. And since I want to create a histogram is normally present on the X-axis. So what I'll do is I'd want to analyze, let's say, this age column. So what I'll do is I will map the age column onto the X aesthetic, and since I want to create a histogram, I will just write down geom histogram over here, and this is what I get. Now let me zoom this. So when I zoom this, this is what I get. So let me also go back and understand what exactly is the age column. So if you see this, your age column tells you proportion of owner occupied units built prior to 1940. So this is what I am getting over here. Now again, similarly, let's say I'd want to understand the nitrogen oxides concentration. So if I'd want to understand the nitrogen oxides concentration, I'll just remove this, and inside this I'll put in NOx, and this is what I get. So here, this is nitrogen oxides concentration, parts per 10 million. So when we say parts per 10 million, let me again zoom this properly so you guys can see this, right? So most of these houses, you will see that we have around 0.45-ish, a concentration of nitrogen per 10 million, right? So this is quite an interesting observation over here. So now this is the plot. If I want to add some color to this, that is something which also can be done. So this is the command over here. Inside this command, what I'll do is, so I have something called as fill. I'll set fill is equal to green. Now when I do that, you will see that automatically the color of this histogram has changed to green. Now I can also add a boundary color. To add the boundary color, I have another attribute called as COL, and for COL, let me say, let me just give in dark green over here. I'll write down dark green, and this is what I get. So I have created this beautiful histogram for this particular column, which is NOx. So I can do all of these basic exploratory data analysis. I can perform visualization on this. Similarly, let's say from this entire, so I've got 506 entries over here or 506 different houses over here. Now what I'd want to do is I'd want to extract all of those records where, so let's say if I'd want to check all of these, I'd want to check all of those records where the Knox percentage is greater than, let's say 0.7, right? So for that, now this is a bit of data manipulation. For that purpose, I have a library called as deployer. So I'll just write down library of deployer. I've loaded it, and inside the deployer library, I have the filter method. Now, first I'll give in the name of the data frame, which is Boston. From this Boston data frame, what I'd want to do is I'd want to extract all of those records or all of those houses where the Knox value is greater than 0.7. So I'll just give in the condition Knox is greater than 0.7. And I'll go ahead and store this in, let's say, Knox 0. Let me just write in Knox great. Now, view of Knox great, and let's see what do we get over here. So, in this new data frame which I've created from the original Boston data frame, if you look at this Knox column, you will see that all of the values are greater than 0.7. Right, so this is quite interesting. So here out of the 506 houses which we have, 61 houses there, the nitrogen levels are greater than 0.7. This is quite interesting. And this is the median price range of the houses where the Knox value is greater than 0.7. Quite an interesting observation, isn't it? Similarly, what I want to do is, let's see what is the tax column about. So tax states that full value property tax rate per $10,000 doesn't really give me much information. Then we have RAD as index of accessibility to radial highways, weighted mean of distances to 5 Boston employment centers. Then we've got, let's check RM. So RM tells me average number of rooms per dwelling. Now I'd want to check this. So here what I'll do is, again, I'll create a histogram for RM, ggplot data, and for this I will map in RM data is equal to RM, and then I would need the aesthetic layer, and for this I will map RM onto this. And since I need to create a histogram, I'll just write down geom histogram over here. So seems like there is an error. So inside data, I would actually need to pass in Boston. This wouldn't be RM. Now when I hit enter, you will see that I get this beautiful histogram. And let me zoom this over here. And you would see that we've got this beautiful plot over here. And this would tell you that out of all the houses, most of the houses, they have around 6 to 7 rooms, right? So if you see this, the peak, it sort of starts around 5.5-ish and it drops at 6.5 or near to 7. Now, I'd want to have a glance at all of those houses where I have, let's say, around greater than 6 rooms. Let me give in that condition. So what I'll do is, I'll give in a new condition over here. So from all of this different houses which I have, from that I'd want to extract only those houses where the number of rooms are greater than 6. So I'll give in this condition filter where RM is greater than 6, and I'll store this in RM6. View of RM6, and let me see what do I get. Here, if I show you this particular column over here, so out of the 506 records, you will see that 333 records, the RM value is greater than 6. So in all of these different house samples, you will see that the number of rooms are greater than 6. So all of this different information I can find out from this. Now that I have done the basic data analysis, I can go to the model building process. Now, in any data science lifecycle, it is important that you understand your data first, understand all of the variables first, and then go ahead and build your model. So that is why we had done the basic pre-processing. Now that's done, I can go ahead and build the linear regression model. Now to build this model, I have this method called as LM. So LM stands for linear model over here, and with the help of this, I can create a linear regression model. Now, the first parameter is a formula. What does that formula take in? It takes in the dependent variable and whatever independent variables we have. So my dependent variable over here is MEDV, which is the average price of the house, and that is what I want to predict. So here Y is equal to MEDV. Then I just given this tilde symbol, which you can consider this to be sort of equal to. So MEDV is, then I need to give in your independent variable. Now I'd want to understand what is the price range, or what is the median price range of these houses with respect to, let's say, the RM value. Let's say with respect to the number of rooms, I'll just give in RM over here. Now both of these columns, where are they coming from? They are coming from the Boston data set. So I'll just set data is equal to Boston. Now I'll go ahead and store this in, let's say, mod 1. Now let me print out mod 1 for you guys. So this is the linear regression model which I've built. And since linear regression is nothing but your equation of linear line, which is y is equal to mx plus c. Here y is MEDV, x is RM. Now what is m, what is c? So here m, this is the value 9.102. So 9.102 is your slope. Now you can also take it this way. So with every 1 unit change in x1 value, there is 9.102 units change in MEDV if your constant is 0. So here this is your constant, and this is equal to minus 34.671. Alright, so we built this model. Now after this, I also need to predict values, isn't it? So to predict the values, I have something called as the predict method. Inside this, I'll just pass in the model which I've just built, which is equal to mod 1. And I'd want to predict in, obviously on top of the same data set, which is Boston. So let me write in Boston over here, and when I hit enter, you will see that I've got all of these values. What are these values? These are the predicted values of the houses. So here you will see that for this record, the first record, the actual value is 24. The model which I've built, it has predicted the average price to be 25. Close enough. Here, the average price is 21. It has been predicted 23. It's a bit far off. Now, also you'd have to understand that this is in thousands of dollars, right? You are not selling a house for just $24. So that's $24,000, right? If I'm not wrong over here, let me check this again, right? So median value of owner occupied homes in $1,000. And that's correct. All right. So now I'd want to have a glance at this. So have I stored it somewhere? I have not. Now what I'll do is I'll take this command and I'll store it in, let's say, Boston predicted. And let me have a glance at this view of Boston predicted. And okay, so this is what we actually have over here. But what I'd want to do is I'd want to combine this and this. So I'll just write down cbind, and I'd want to combine the actual prices with the predicted prices. The actual prices are present in this column, MEDV column of Boston. So I'll write down Boston $MEDV, and the predicted values are present in Boston predicted. Let me write it properly. Boston predicted, and let me hit enter. Now let me store this, and I'll have something called as a full house because I've recently started playing poker, and since this is the actual values, I'll give the name of the column as actual, and since these are predicted values, I'll give the name of the column as predicted. Let me hit enter. The view of full house, and this is what we get. So these are the actual prices of the houses, and these are the predicted prices of the houses. Now you'll see that there's a difference in prediction, and that difference between the actual values and the predicted values is what is known as the error in prediction. And your best model needs to have as less error as possible. So that is how you get the optimal model. Whichever model has the least error, that would be your best fit model. Now, how do we find that? Well, for that purpose, let me just go ahead and calculate the error. So here, this is actually a matrix. Let me convert that to a data frame first. So I'll write down as dot data frame full house, and I'll store it back into full house. Now that I have this, I'll have full house dollar actual minus full house dollar predicted. So actual minus predicted, this will give me the error in prediction. Let me take this properly over here. And I'll store this in a new object and I'll call that as, let's say, error 1. Now I'd want to combine error 1 back to this data frame. So again, I'll use cbind. Inside this, the first parameter would obviously be full house, and along with full house, I'll have, what do I need to have? I need to have error 1, and I should store it back to full house, and this is what I get. The actual values, the predicted values, and the error in prediction. And now, so error seems like I've not calculated this properly, so I have written over here actual minus actual. So let me redo that. Let me change it to predicted and I'll store it back in error 1. And now cbind full house error 1, I'll do this. So here, or let me just store it in full house 1. All right. So now that I have this extra column, what I can do is I can just drop it from here. So for that purpose, I'll again use deployer, which I have already loaded. I'll write down Boston. And from this, I'll use the filter method. And inside the filter method, I actually need to use the select method over here. Select, I'll give in all of the names of the columns. And the names of the columns are actual, I would need predicted, and I would need error 1. Let me store this in full house and let's see, actual doesn't exist. Let me go ahead and remove these over here. I have actual, so this is also full house, this is not Boston. Let me change it to full house. I have actual, I have predicted, I have error 1. So from this full house data frame, I need to select these, error 1 at location 3s and 4. Yes, correct. So what I'd want to do is I'd want to select only the actual and the predicted. I'll also remove error 1 from over here. I'll store it back. Right. So now that we have this, now I can perform the same operation properly. So I'll write down full house dollar actual minus full house dollar predicted. And I'll go ahead, copy this, paste it over here. Once I do this, what I want to do is I'll store it back in something called as error final, and I'll combine this with error final. So cbind of full house, and I'm combining it with error final. I shall store it back to full house. And this is what we have. So here we have the actual prices, the predicted prices, and the error in prediction. And now, if I want to somehow find out the average prediction over here, what I can do is I have something called as root mean square error. Let me write that down over here, root mean square error, which would mean that this error which you see, first you take the square of it, then you take the mean of it, then you take the root of it. So if you have to compare the accuracy or the optimal level of your two models, then whichever model will have the lower value of root mean square error, that would be better. So here what I'll do is I'll perform root mean square error. So for that purpose, I would first need to take the error. So full house dollar final error. And since I want the square of it, I'll do this. Now, since I have the square, what I want is also the mean of it. So again, I'll copy this, I'll paste it over here, and I'll get the mean of it. Now, after I get the mean, I would also need the square root of it. So let me copy this entire thing. I'll paste it over here and I will just write down SQRT. Let me write that down properly over here. So I have root mean square error, and this is the result which I get. So I have a value of 6.603, which is the root mean square error of the model which I've just built. And let me go ahead and store this in something called as RMSE1. So till now we've built a model directly on top of the data set. But the problem with that is what we're doing is we are overfitting the model. Now what exactly is overfitting? Well, if we fit the entire model on top of a singular data without testing if the model is working properly, that is known as overfitting. So let me give you guys an example. And now let's say you guys are giving an exam, and in that exam somehow let's say the question paper leaks. So let's say your friend comes up to you and says, hey, we've got these 5 questions which will definitely come in the exam. So let's say the exam is of only 5 questions and you already know which of those 5 questions are going to come in the exam. So now, since you already have the leaked question paper, and if you learn all of those 5 questions properly, and now if you go and sit in the exam and if the same questions appear, well, you'll obviously get full marks out of them. But what if that information was incorrect? Now, let's just assume that somehow the paper got leaked, but maybe all of those 5 questions are incorrect. Those are not the questions which you'll be getting in the exam. But what happened was you prepared for only of those 5 questions instead of preparing the entire syllabus. Now when you appear for the test, you'll get 0 out of 5 instead of getting 5 out of 5. So that is why it is always important to divide your data into training and testing sets. Now what you do is you build your model on top of the train set and then you test it on top of the test set, obviously. So in this way, what you're avoiding is overfitting of your model. Now, once that is clear, my idea or my aim right now would be to divide this entire data set into training and testing sets. And normally we take a 65-35 split or a 70-30 split. So this is normally the norm, but then again, that is totally trial and error. So what I'll do is I'll divide this into 2 separate sets. One would be my training set, another would be my testing set, and I'll be building my model on top of the training set and I'll be testing it on top of the test set, obviously. And for that purpose, I would need a library called as CA tools. Let me just go ahead and load that. I'll just write down library of CA tools, and this will provide me a function called as sample.split. Let me write it down properly over here. So this is the function. Now, as you see over here, this takes in 2 parameters. The first parameter is basically the column which I'd want to split, and the column is this one, MEDV column, and then I'd want to split it in a ratio of 65-35. For this, I'll just write down Boston, and then I need to give him the name of the column which is equal to MEDV. After that, I have a parameter called as split ratio, and inside split ratio, I'll give in a value of 0.65. Now, what this means is, out of this entire data frame, 65% of the records will get a true value and the rest of the 35% of the records will get a false value. Now, I'll go ahead and store this in a new object and I'll call that as sample tag. Let me just print out sample tag for you guys so that you can understand what is present over here. So you just see that these are just a bunch of true and false values. And by default, you'll have 65% of the records to have true value. The rest of the 35% of the records to have the false value. Now, I'd want to only extract the records. I don't want the true and false values. So for this, what I'll do is I have a method called as subset. Now, the subset function obviously helps us to create a subset from the original data frame. So what is my original data frame over here? That is this Boston data frame. I'll go ahead and give in the name of the data frame, which is Boston. Now, from this, what I'd want to do is I'd want to extract all of those records where the sample tag or the value in the sample tag is equal to true, which would mean that I'm extracting the 65% of the records from this entire data frame. and I'll go ahead and store it in a new object, and I'll call that object as train. Similarly, so here as you see, my original data frame had 506 records. Here on the right side, if you look at this environment pane, global environment pane, you will see that I've created a new data set called as train, and it has 353 observations. So of the 506 observations, 353 have been recorded or have been stored into the train set. Similarly, from the entire Boston data set, what I'd want to do is I'd want to extract only those records where the sample tab is equal to false. So I'll extract all of them and I will store that in something called as test. Again, here you shall see that I have 153 records in this test set. Now, let me have a glance at the training set and the testing set. So view of train, and this is what I get. Similarly, I'll write down VU. Inside this, I'll give in test, and this is what I get. So from the Boston dataset, I have been able to create two subsets, which are the training subset and the testing subset. And now I would have to build the model on top of the training set, and we already know what are we supposed to do. So here I have a method called as LM. So I'll just write down LM, which would stand for linear model. Now in this, as you see, I would need to give in the formula. So in the formula, I would have to first give in the dependent variable, and then after that I would have to give in all of the independent variables. So here the dependent variable is the MEDV column. So I'll write down MEDV and then I'll give in the still symbol. And then I'll follow it up with the independent variable. So again, I'll take the RM, which is the number of rooms over here, as the independent column. And this time, this formula or these data points are coming from the train set. Right, so I'm taking this only from the train set, not the entire Boston data frame. This will give me a model. Let me call it as mod. I'll take it as mod 2. Now let me print out mod 2 for you guys. So here, this is the LM formula which I've applied. Here I have the RM value. So this would mean that by 1 unit increase in the RM value, there is 9.695 units increase in the MEDV value. And we have the intercept over here, which is minus 38. After this, what I want to do is I can just go ahead and predict these values on top of the test set. So if I am going ahead and predicting the values, I would obviously need the predict function. I'll write predict, and inside this, I would need to pass in the model which I've just created, which is mod 2. Then going ahead, the data which I'll be using is the test set. So obviously I have trained the model on top of the training set. Now it's time to test it on top of this test subset. I'll go ahead and I shall store it in something called as result MEDV. Now let me print out result MEDV for you guys. So these are all of the predicted values. Now I have to compare the actual values with the predicted values. So where are the actual values? Well, you can find the actual values in the test set. So in the test set, you see this MEDV column. These are all of the actual values. This value which you see 24.0, for that we have predicted 25. You have this value 33, for that we have predicted 29. Similarly, you have 28 over here, for that we have predicted 24. Now, I'd have to combine these actual values with the predicted values. Let me go ahead and do that. So I shall use a method called as cbind, and here I'll give in the name of the first column as actual, and I am getting those values from test $MEDV, and the predicted values are coming from result MEDV. This again I will name as predicted, and I shall go ahead and store it in a new object. I shall call that new object as full house 2. Let me have a glance at this view of full house 2. So here I have the actual values, here I have the predicted values. Now I need to find out the error. And before I do that, I need to convert this matrix into a data frame. So as dot data frame, inside this, I shall pass in full house 2, and then I shall go ahead and store it in full house 2 again. Now need to find the error. Full house 2 $actual minus full house to dollar predicted. And let me copy this entire thing over here and paste it inside this. And I shall store it in something called as error2. Now I can combine error2 with this full house 2. Cbind of full house 2 with error2, and again the result would be stored in full house 2. So here I have the actual values, the predicted values, and the error in prediction. Now if I am supposed to find out an average error for this entire model or the average accuracy, I have something called as root mean square error, and we know that lower the value of RMSE, the better the model is. So here I already have the error. So let me take full house 2. The name of the column is error2. I need to start off by taking the square of this. Okay, let's do that. So I have taken the square of this. After taking the square, what do I need to do? So it is root mean square. So I need to take the mean of it. And after I take the mean of it, I would also need the square root. Let me cut this out from here and paste it inside this. I would also need square root. So root mean square error, and let's see what do we get. So we get 7.06. This is interesting. I'll go ahead and store this in RMSE2. Now what I'd want to do is I'd want to add another independent variable into this. So I'm just throwing one more predictor into this model, and I'll see if the RMSE value reduces or if it increases. So I have this over here. Now what I'd want to do is I'd want to understand the price of the MEDV or the price of the house with respect to the number of rooms and also the Knox value over here. So this time I shall create a new model. I don't have to divide my training and testing set again because I shall be using the same train and test. It's just that I will have a new model where I have new independent variables or a new composition of independent variables. So in the earlier model, we only had this RM value as the independent variable. So we are building a new model in this. My dependent variable would be MEDV. Now after this, I am using I'm using RM as one independent variable. And after this, I'm also using Knox as another independent variable over here. Now, these both values are coming from my training set. So data is equal to train. And I'll go ahead and store this in a new object. I'll call this as mod3. Now when I print out mod3 over here, you'll see this formula. Here you have formula as MEDV RM plus Knox. Now you'd have to understand over here that whenever we are building the linear regression model, the model assumes that the independent variables, obviously they are independent of each other, which would mean that RM does not influence Knox and Knox does not influence RM. Which would mean that if I'm trying to predict the price of a house with respect to RM, then NOx does not influence it, right? So you would have to understand this properly over here. And also there is one more assumption. So the assumption is there is a linear relationship between your independent variables and the predictor. And now what happens is whenever there's a lot of collinearity, what exactly is collinearity? So let's say if there is collinearity between RM and Knox, that would mean that, well, you can sort of assume that both of them are sort of saying the same thing. And both of them are sort of saying the same thing. It is not really viable to include both the variables into your equation. What you can do is you can use one of them into the equation. So that is why it is better to have different types of independent variables in your data to reduce collinearity and also to get the optimal result. So here it seems that there is a linear relationship sort of between RM and MEDV, and there is an inverse relationship between Knox and MEDV. Which would mean, that is sort of intuitive, isn't it? If the nitrogen levels increases, the price of the house would increase. If the number of rooms would increase, the price of the house would increase, right? So I'll repeat it again. If the number of rooms increase, the price of the house would increase. But if nitrogen levels increase, or what exactly is this? I believe this is nitrogen only if I'm not wrong. So this is nitrogen oxide concentration. So if the nitrogen oxide concentrations increase, then the house price would decrease because probably you can not habitat over there that easily. So you would have these sort of problems over there. And now when I've built this model, I want to compare the accuracy of this model with my earlier model, which was mod 2. So again, for that, what I'll do is I'll use the predict method. Inside the predict method, again, I need to take in mod 3. Now, new data is obviously the test data, and I shall go ahead and store this in, let me call this MEDV result. So just the opposite of the earlier one. Now that I have this, what I'd want to do is I'd want to combine the actual values with the predicted values again. So the actual values are obviously present in test $MEDV and the predicted values are present in MEDV result. This I'm going to name as actual, and this I shall name it as predicted. Now I will go ahead and store this in full house 3. And let me have a glance at this view of full house 3. And as you see, I've got the actual values, I've got the predicted values over here. So this is the test set. This is what I have over here. Now, here if you see, look at the value, 24 is the actual value. The predicted value is 25. Similarly, the actual value is 33, predicted value is 30, the actual value is 28, the predicted value is 25. Obviously, there is error in prediction. Let's calculate that error right now. So to calculate the error, I again need to convert this into a data frame. So as .data frame, what do I need to do over here? I just need to pass in full house 3 over here and store it back to full house 3. Now that this is done, let me go ahead and calculate the error. So full house 3 $actual minus full house 3 predicted. Let me copy this, paste this inside this, and cut this out over here. So actual minus predicted, this will give me the error, and I shall store that in error 3. Now I can go ahead and combine this error with the actual values again. So here I shall have full house 3 I actually need to combine this, so I would need to use cbind over here. Original values are present in full house 3, and I need to combine the error, which is error 3, and I will store it back into full house 3. I've got the error column as well. So now that I have the error column, I can again go back, find out the RMSE value. What exactly is RMSE? RMSE stands for root mean square error. So let me go ahead and calculate the square first. Full house 3, I'll give in a square over here. Let me copy this, paste it inside this. Let me cut this out over here. Then I would need the mean of it. Let me cut this out, paste it over here, and I would also need the square root of it. So root mean square error. So here this is actually full house 3 $error 3 power 2. Now let me hit enter. I have a value of 6.79. Now let me compare this with RMSE2. So in RMSE2 we had only one independent variable, which was of RM, or the number of rooms. Now here we are taking the mixture or composition of two variables, which is of NOx, which is the nitrogen oxide concentration levels, and I also have the number of rooms. So it would seem that this model which I have built is much better than the earlier model. I wouldn't say much better, but slightly better. So this is the RMSE value for the model which I built. So obviously lower the RMSE value, better your model, because RMSE stands for root mean square error, which again, if you want to intuitively understand this, lower the error value, better the model it is. So this is how we can create different models with permutations and combinations of all of the independent variables, and we can come out with the optimal model. Now we'll be implementing linear regression with Python. So for that purpose, I have opened up Jupyter Notebook over here. And in this, I have a kernel opened up for Python. Now we'll be implementing this linear regression algorithm on top of a dataset called as Iris. So to load that dataset, I would need the pandas library. So my first task would be to go ahead and load that library. So here I shall just write down import pandas as pd. Let me run this. So after loading this, what I would have to do is go ahead and load the file. Here I shall write down pd.read_csv. So this is the method with the help of which we can load a CSV file with the help of the pandas library. So here pd.read_csv, the name of the file is iris. So I shall give in the complete name, which is iris.csv. And I shall store it in a new object, and I shall call that object as iris as well. I have loaded this. Now, let me have a glance at the first few records of this data frame. So as we had the head method in our studio or our programming language, similarly, we have the head method in Python as well. So here I shall write down iris.head, and by default, I'll get the first 5 records in this data frame. And as you see, I've got all of these different columns over here. I've got sepal length, sepal width, petal width, and species. So this iris flower basically has 3 different species, which are setosa, versicolor, and virginica. And I have the different features of these different species. So these features are the sepal length, sepal width, petal length, and petal width respectively. Now what I'd want to do is I'd want to understand the relationship between sepal length and petal length. And for that purpose, I'll be building a linear regression model. And here my independent variable would be sepal length and the dependent variable would be petal length. So here I'm basically trying to understand how does petal length vary with respect to sepal length. Now, for that I'd have to extract the predictor and also the dependent variable. So predictor, which is sepal length, let me go ahead and store that in a value called as x. So here I'll have a data frame. The name of the data frame is iris. Obviously, here I'll give in 2 braces, and the name of the column is sepal_length. So from this iris data frame, I'm extracting this sepal length and I'm storing it in this object called as x. Similarly, I'll create a new variable called as y, and in y I'll be storing petal length, which would be the dependent variable. So I'll have iris. Let me write down petal length over here. So now that I have the dependent variable and the independent variable, now it's time to divide this data set into training and testing sets as well. So to divide this into training and testing sets, I would need something else from the sklearn library. So sklearn is the scikit-learn library, which is normally used for machine learning purposes and a bit of computation. So using this library, what I'll do is I have something called as the train test split method, and using the method I will divide this into training set and the testing set. From, let me write it down properly over here, from sklearn.model selection import train test split. So now that I have imported train test split, what do I need to do? So let me write down train test split over here again. I'll pass in the predictor and the dependent variable. So x, y, and I need to set the test size as well. So I'll give in the test size as 0.3, which would mean that 30% of the records would be in the testing set and the rest of the 70% of the records would be in the training set. Now this will give me 4 outputs. So I shall go ahead and store them in something called as xtrain, xtest, ytrain, and ytest. So I have xtrain, xtest, ytrain, and ytest. So xtrain is the training set of the independent variable. Xtest is the testing set of the independent variable. Then I have ytrain, which is the training set of the dependent variable. And then I have the ytest value, which is the testing set of the dependent variable. So I'll get all of these 4 outputs. Now from these 4 outputs, we have already seen that if I'd want to build a model, I'd want to build it on top of the training set. And if I'd have to predict something, I'd want to predict it on top of the test set. So now I would need the linear regression model. So again from sklearn, let me go ahead and import linear regression. So this time I'll write down from sklearn.linear model import linear regression. So now that I have imported linear regression, let me just go ahead and create an instance of it. Here I shall write LR is equal to linear regression, which would mean that I am creating an instance of this. So now that I have created this instance, I would have to go ahead and fit this on top of the train set. So I will write lr.fit, and my train set comprises of the x train value and the y train value. X train, comma, y train, and I have fit this model successfully on top of the train set. Now it's time to predict the values. So to predict the values, I'll use the predict method, and inside this I will give in x test, and I would have to type lr.predict actually, and when I give in lr.predict, you will see that these are all of the predicted values. Let me store the predicted values in a new object, and I'll call that new object as ypred. So now I've got my actual values which are there in y-test and the predicted values which are there in ypred. So let me just show you a glimpse of both of them. I'll have y-test.head, then I'll have ypred, and I'll give in 0 to 5. So here, as you see, these are the actual values, these are the predicted values. So if the actual value of petal length was 4.1, my model predicted that the value is 3.35. Similarly, when the actual value is 1.7, the model predicted that the value is 3.53. Here you see that the actual value was 5.3, the model predicted that it was 5.001. So we have the actual values and the predicted values. Now we'd have to find out the mean squared error. So here I don't have to separately find out the error by subtracting the actual value minus the predicted value. I already have a predefined method called as mean squared error in the sklearn library, and I can just go ahead and use that. So here I will write from sklearn.metrics. So from sklearn.metrics, I would have to import something called as mean squared error. And now that I have imported this, let me use this over here, and inside this I'll just pass in the actual values which are there in y-test, and then I can pass in the predicted values which are there in ypred. Now when I hit enter, you will see that I get this value of 0.70, which is the mean squared error of the model which I've built. So folks, this is how we can also build a linear regression model in Python. Thank you.
Hello everyone and welcome back to our channel. In today's session, we will be talking about the most brimming topic of the hour, the recommendation engine and how it works. Without wasting any more time, let's quickly jump into this video. What do you think when the word recommendation comes to your mind? Imagine a scenario where one of your closest friends recommends you to watch Money Heist on Netflix, or your sister wants you to watch Friends, and your mother wants you to spend some time watching a Planet documentary. Are these recommendations based upon what they like or what you like? The question is pretty relevant. However, what if there is someone who understands your choice and recommends something you want to watch? Well, that's today's topic. Recommendation engine. Before we start our today's discussion, make sure you hit the subscribe button to keep receiving notifications for our masterclasses, interview preparation videos, and so much more. Here's everything you need to know about recommendation engine. What is a recommender system? In today's digital world, where people spend most of their time watching Netflix or Amazon Prime, the recommendation system is the most potent marketing tool. A recommender system is nothing fancy but an automated information filtering system to filter some entities composed of machine learning and AI algorithm which predicts what the customer wants to see. These entities can be any possible product such as ads, movies, TV shows, songs, and so on, which we see on apps like Netflix, Amazon, and YouTube on every day. Today, the e-commerce space is loaded with information. With hundreds of movies and shows released every day, a recommendation system helps tackle this challenge and saves customers a lot of time while browsing the internet. The recommendation system automatically directs the user to the product they will mainly like. Now let us understand this via example. Say we watched a movie today and then later we got recommendations for some different movies based on previous viewing history. Other than movies, it could also be a product that we bought and then we get a recommendation for a similar product based on the power of previous viewing history. Note, the recommender system not only works in what products are being shown, but also in what order the products are being ranked. The idea of a recommendation engine is not new. It is something you are already familiar with. Excited to know? Do you watch movies on Netflix or spend time shopping on Amazon or follow the recommendation made by YouTube for music? If yes, you are already supporting the recommendation system in many aspects unknowingly, which enhances your online experience. Now, when you have understood recommendation system, it is important to understand why the recommender system is built. Without any further ado, let's see why this is important. Imagine, what if you are left on Netflix between tons of movies to find your favorite one, or on YouTube to find which song you like the most? It will be a brainstorming session. That's exactly why recommendation engine is important. Businesses are showing us recommendation and relevant content for a couple of reasons. For one, most companies think they understand their customer, but often customers can behave much differently than businesses you ever think, as their choice fluctuate with time. So it's important to show the users what is relevant to them and match their choices while also sharing new content which might grab their attention. As mentioned earlier, the internet is flooded with good content. Therefore, you need a tool that bifurcates your choices from the horde of information present on the internet today. The recommendation system serves to help us solve the information overload problem and helps us narrow down the set of choices. It helps businesses sell more relevant content that might attract users and make them stick forever. From the customer's perspective, the recommender system helps save valuable time and showcases what interests the user. However, from a business perspective, it helps to understand better what the user wants and might want in the near future. So how does the recommendation engine work? Now, when you have understood exactly what the recommendation engine is and why it is necessary today, let us understand how it works. How does the recommender system work? Imagine you like your pizza with tomato toppings. How does your mom know that you like tomatoes on your pizza? The best and the easiest way is that she could have asked you specifically if you want tomatoes, or she must have watched you from a distance while ordering pizzas. A recommender engine is nothing different. Instead, it almost works the same way. It will either ask you what you prefer or see what kind of content you are regularly watching. Say you like family shows, then it will mostly recommend similar content which will hook you to watch more. And even if your mom knows you well, maybe a machine learning algorithm knows your choices even better. For example, when you go to Netflix or any other services which are mostly based on recommendation, the first time you go there, they ask you what your taste buds are, whether you prefer horror shows or comedy series. Have you ever thought the reason behind this? Well, it's to understand what the user may like and recommend the same to grab the interest in the very first go, as they are completely clueless about your choice, as they have never interacted with you personally or digitally. For any service, you are a valuable asset. Therefore, they are bound to be treated like king and queens. It's called the cold start problem, where they have no idea of who you are and have no profile for you. Therefore, they will force you to at least put in something, say what movies you like, what are your food choices, what singer you must love the most, what genre grabs your attention, because how will they know otherwise? Let us understand how YouTube recommendations work. YouTube videos are mainly dependent on three factors: watch time, videos that have a lot of watch time, then engagement, and finally topic relevance, which means the video is relevant to topic I am looking for. Another factor that plays a vital role in video recommendation is the user's history. Say you continuously watch a particular YouTube channel. You will regularly recommend videos of them and content similar to theirs. If I watch a trailer of Avengers Endgame, the stakes are high that I'll recommend the trailer of Iron Man or behind the scenes of Avengers Endgame. Note, these algorithms are supremely smart, which know what to show you when, and they can be highly accurate. It should also be noted that there are higher chances that each company, including YouTube or Amazon, might have its own recommendation engines or a specific way of generating recommendations, as one company's method of recommendation might not apply to another company or all. What are the different types of recommendation engine? Before understanding how the Netflix and Amazon recommendation engine works, it is important to understand the different types of recommendation engines. Broadly, the recommendation engines are divided into two parts. Collaborative filtering. Collaborative filtering is a type of recommendation engine which majorly focuses on understanding and analyzing the customer's behavior, preferences, or activities to suggest reliable product or services. Here, a large part of information is collected depending on a customer preference to see what the customer might like. Amazon is one of the biggest examples of collaborative filtering as it works on collecting preferences from distinct sources. Techniques involved in collaborative filtering: non-probabilistic algorithm, user-based nearest neighbor, item-based nearest neighbor, reducing dimensionality. Next up, probabilistic algorithm, Bayesian network model, EM algorithm, content-based system. The content-based system deals with the idea of if you like a particular product, you will like the similar products too. Here, the machine learning algorithm suggests products that are similar to the user's history. For example, if a person likes horror movies, the system will recommend movies from the same genre repeatedly. How does Netflix recommendation work? The success of Netflix is mostly dependent on the recommendation engine. Whatever they do is based upon what the recommendation engine suggests. Record says 80% of people who play on Netflix comes from Netflix recommendation algorithm. So it's really big lever for Netflix. In a world where there are so many cultures and people with different tastes, it's hard to please everyone at the right time with the right content. And that's where recommendation engine enters. Here is the science behind Netflix. Whenever you click on the Netflix tab, the recommendation system gets ready to direct you to the right source of information you might be looking for. Netflix estimates your action based upon your number of factors, including your interaction with the services, say your search history or your most recently watched show, other members who have similar taste or presence as of you, information about the title such as the genre you most likely to watch in, actors you love the most, categories, and so on. In addition, to know what you love watching on Netflix, they personalize your experience based upon the time you watch Netflix, the device on which you are watching Netflix, for how long you are watching Netflix in the entire day or one sitting. All these pieces of data may not matter to you. However, they are most important source of information by which Netflix knows you better than everyone. When you create your profile on Netflix for very first time, you must have noticed that Netflix asks you to choose a title you prefer over others. Once you start to select the options, the Netflix recommendation engine starts to bifurcate your choices and presents you with everything you would want to watch. Apart from Netflix, another platform that is gaining immense popularity these days is Amazon. Let's discuss how Amazon recommendation engine works. How does the Amazon recommendation engine work? Amazon, being a multi-billion-dollar estate, many emerging companies look up to Amazon and its magic ingredient, which made it the world's most visited e-commerce website till now. Note, Amazon heavily believes in data-driven marketing. If you see something that you like and something pops up that matches your preferences, understand the recommendation engine is working at its best and throwing some great results. The choice you make on Amazon are based upon three significant factors, including events, rating, and filtering. Let's start with events. Amazon stores and tracks data on all custom behavior and activity on the site. Every time you search something on the search bar, say you type laptop, a record of the event is logged in the database and the entry is stored as something like user A clicked on X product. Whether you like a product, add a product to the cart, or purchase a product, your actions are captured, which promotes future purchases. Next on the list is ratings. Ratings are an essential component of every e-commerce website, including Amazon, because it unveils how the customer feels about a particular product. Here, the maximum rating is 5-star. So in case the user truly loves the product, he can easily give it a 5-star. The last in the list is filtering. Filtering products are based upon rating and other user data. Amazon recommendation engine use three types of filtering: collaborative, user-based, and hybrid approach. Let's discuss each of these. Collaborative filtering. In collaborative filtering, the visitors' choices are compared to each other and based upon that, they are recommended the most suitable product. user-based filtering. The second one is user-based filtering, in which users' browser history, cart item, purchases and likes play a significant role before providing recommendations. With this, we come to the end of our session. Now that you have learned what the recommendation engine is and its functioning, we would love to hear your views about the same in the comment section below. If you guys have any queries or questions about what we just discussed, you can leave them in the comment section and we will get back to you. Before leaving, let's quickly have a summary of what we discussed today. We started our today's discussion with the recommendation engine, where we understood the AI algorithm through an example. Then we briefly discussed why the recommendation engine is so important. Later, we talked about how it works and various aspects which are taken into consideration. In the end, we also discussed the Amazon and Netflix recommendation engine works. If you like this video, don't forget to hit the like button, share and subscribe to our channel. Don't forget to press the bell icon to be notified every time we upload a video. We will see you next time. Bye-bye. Hey you guys, welcome to this session brought to you by Scalers Academy. You guys must have come across the term image processing and must have wondered what it is and how it works. In this session, we will learn about everything. We will learn about image processing. The major topic to be covered in this session includes what is image processing, steps involved in image processing, what are the libraries that are involved in image processing, why do we need image processing, and lastly, what are the steps involved in image processing. But before we get into this, make sure you hit the subscribe button so you keep receiving all the fun, informative and insightful videos by Scaler. Now let's get started. What is image processing? Image processing is a way of imaging using digital computers where you can get an enhanced image or extract other useful information from the images. In this method, some operations are performed on an image or video frame. It is a type of signal processing in which image or video frames are input and the output may be an image or characteristics, features associated with that image or videos. In today's time, image processing is one of the rapidly growing technologies. Image processing forms a core research area within computer science and engineering disciplines too. Digital image processing may be editing of any video, audio that exists in image using a digital computer. It is the way to do something in the existing image by enhancing the image or cutting out something useful from it. In simple words, image processing is the analysis and manipulation of a digital image to improve its quality. The most common example of image processing applications is Adobe Photoshop. These are three basic steps: importing an image, analysis and image management, and the result. But image processing involves many complex steps to reach the result that are required. Now we will discuss these steps in brief to understand what goes in the processing of an image or a video or any digital copy. Steps in image processing, starting with image acquisition. Image acquisition refers to the action of acquiring or retrieving the image from the source such as camera or sensor, etc. This is the first step of image processing. Without image acquisition, no image processing is possible. Number 2, image enhancement. Image enhancement refers to the process of changing the image according to your need. It can include actions such as sharpening the image, turning off the sound of the video, turning on the image, etc. to make the identification of its key features easier. Image restoration. Image restoration is a function that is used for taking the noisy image and measuring a new image out of it. Restoration can happen in various ways such as at camera focus, sound and action blurring. The aim of image restoration is to lessen the noise in an image and claim back the loss of decision. Coloring image processing. Color image processing needs the understanding of the physics of color as well as light and vision psychology. Separation of image processing is used for the aim of color processing. Wavelets processing. It refers to the process of image representation. Wavelet is an efficient tool used for image representation. It helps in getting multiple solutions of the image by allowing investigation. Next up, image compression. Image compression is a form of data helpful for photography and it decreases costs. It is the process of minimizing an image in a way that does not affect its quality. Character recognition. OCR refers to optical character recognition, which is an electronic or machine operated replacement of scanned copies or text that is readable by the system. It is used to access records from emails, paper, business cards, invoices, etc. It is used as a common way to create digitally printed manuscripts for those that can be stored, sorted, and searched in the processes like text-to-speech, machine conversion, and display online, retrieval of key data, and text mining. What are the prerequisites of learning image processing? First, you must have a basic understanding of the program in any language. Secondly, you should know how an image is presented in memory to start your journey of learning image processing. As in image processing, each image is presented by a set of pixels that form a matrix of pixel values. In the grayscale image, the value of pixel range from 0 to 255 and define the intensity of a pixel. In a color image, you must know that color images have 3 channels: red, green, and blue. So there will be 3 such matrices present for each image. Image processing with Matlab. What is Matlab? Matlab is a platform for programming specifically designed for scientists and engineers to design and analyze products and systems that can transform the world. It is used in photography as a part of lab problems and exercises categories. Why is Matlab used in image processing though? It is a common programming language. It is used in image processing by writing function files and script files to perform the actions. It helps in replicating the result in the case it is needed and testing the final result. Type of images in Matlab Toolbox. There are mainly 4 types of images supported by Matlab Toolbox, which are RGB images, indexed images, binary images, and gray images. Grayscale images. A grayscale image refers to an image where only the shades of grays are present. It is also known as monochrome images. Grayscale images use 8 bit per pixel in the image, where a 0 pixel value refers to black, 255 pixel value refers to white, and the medium value between 0 to 255 shows different shades of grey. Moving on to binary images. These images refer to an image that can only have 2 colors, and each pixel is either color 1 or the other color. The colors in binary images are usually black and white. Binary images use 1 bit per pixel, where 0 usually refers to black and 1 refers to white. These images are presented as 2D columns. A big advantage of binary images is the small size of these images. Featured images. Featured images are those that represent the mood, content, and theme. Featured images refer to a matrix of whole numbers X, in which each number means a specific price line of RGB in the map, which is called the color map. RGB image. In the RGB image, the RGB refers to red, green, and blue. In these images, each pixel is presented as 3 times the value of its R, G, and B objects. RGB image refers to 3D dimensions of size m into n into 3, where m and n are the height and the width of the image, and 3 is the color segment in the image. Applications of image processing, starting with intelligent transportation systems. One of the applications of image processing is the intelligent transportation system used for automatic identification of numbers and traffic signs. Next up, remote sensing. In this application of image processing, the sensor takes images to the Earth's surface on satellites or a screen scanner. The images are processed and used to translate regions and materials that are used for agricultural production monitoring, resource mobilization, town planning, flood management, etc. Next up, moving a tracking object. The app allows you to measure movement and to get a visual record of the moving objects. The various types of trackings are awareness based on awareness, active tracking. Next up, security monitoring. Image processing is used under aerial surveillance systems that monitor sea and land. The application is used to find the configurations and the types of submarines. The important function of the application is to distinguish the many elements that are present in the water body of the image. The various parameters such as cohesion, perimeter, area, width, and length are set out to separate each item. It is noteworthy that the distribution of the items is done on the various sites to define the whole shipping structure. The entire oceanic situation can be interpreted from the local distribution of things. Automatic testing program. The application helps in improving the productivity and the quality of the product in the industry. Some of the examples can include automatic testing of incandescent lamp fibers. This function facilitates automated testing of the process of creating a lamp. General Electric Corporation operates this system. In automatic testing of incandescent lamp fibers, a piece of the binary image of the string of the lamp is created on which a silhouette of a filament is formed. Silhouettes are examined to know the differences in height of the lamp. Automatic phase testing systems. Image processing techniques like fractal analysis, edge detection, texture detection, etc. are used for automated phase detection. Wrong identification. The application helps to identify incorrect items in electronic systems. A large amount of heat energy is caused by faulty parts. Analyzing infrared images can help in detecting such errors. What are the libraries involved in image processing? Image processing libraries, digital data will skyrocket up to 175 zettabytes, and a huge part of this data is image. According to IDC, there are top 8 libraries in Python which are used in machine learning tasks. These are as follows. OpenCV. OpenCV is an open source library that was developed by Intel in 2000. This library is mostly used in computer vision tasks such as face detection, face recognition, image segmentation, etc. It also contains a lot of useful functions that you may use in ML. Scikit-image. It is a library that is Python based that has a few paths written in Python to achieve better performance. It consists of the algorithm for filtering feature detection, analysis, segmentation, color space manipulation, and more. SciPy. It is popular for scientific and mathematical computation. It can also perform multidimensional image processing with its submodule scipy.ndimage. It was the most used image processing actions such as image segmentation, face detection, reading image, feature extraction, etc. Pillow. PIL. Pillow is an open source library used for image processing that requires Python programming language. It can do tasks such as revealing, reading, and saving in various image formats. NumPy. It is a Python-based library that is used for working. It was created in 2005, which stands for Numerical Python. It can easily perform tasks such as image cropping, masking, or manipulation of pixel values. Mahotas. It is another image processing and computer vision library that was designed for bioimage informatics. Mahotas read and writes images in NumPy array and implements them in C++ with a smooth Python interface. It has the most popular functions such as watershed, morphological processing, template matching, etc. Simple ITK. It is an open source platform that is widely used for image segmentation and image registration. In image segmentation, it uses CMake build environment. pgMagick. It is a graphic magic binding for Python that allows options to perform on images such as drawing text, rotation, sharpening, resizing, etc. It allows methods for manipulation of image and editing. Why do we need image processing? Image processing is often viewed as software that improperly exploits the image to achieve a different level of beauty or to support a popular reality. However, this software is not accurately described as a mean of interpretation between human viewing system and digital imaging devices. Digital cameras view the world in a different way from the human viewing system. Digital cameras have additional sound effects and bandwidth. The simple definition of image processing refers to digital image processing where audio editing or any type of conflicts that exist in the image is solved using digital computer. Image processing is a rapidly growing technology in today's time. To wrap up today's session, let's quickly revisit what image processing is all about. Image processing refers to the action of performing certain tasks to an image or any digital copy to create a new and improved copy or to perform the action of extraction of information from the copy. Image processing is one of the largest growing techs today. It is a matter of research in the fields of computer science and engineering. Image processing involves three basic steps. Importing an image. Import an image with an optical scanner or digital photography. Analysis and image management. It includes data compression and enhancement of image and visual detection patterns. Output. In the final stage of image processing, where output can be altered to an image or report based on image analysis. Image processing is of two types: digital image processing, analog image processing. Analog image processing is used for the processing of hard copies such as photography and printing, while digital image processing is used to process digital images by using a desktop. The common data categories that are required to use during digital processing are pre-processing of a copy, development of the copy, and display of information. Thank you so much for watching this video, and we hope now you understand what image processing is. Please like this video and leave a comment below stating which library for image processing you think is the best. And do share this video with your peers. Do not forget to subscribe to our channel if you haven't already. See you soon with another video where we will discuss a new topic. Until then, bye-bye.
We have been
Sure,
talking
sure.
for the last 5 minutes. Hey everyone, so we are live on YouTube and we are live on LinkedIn. We'll just give them a couple of minutes to join in. Okay, so all excited about London. Have you got the first like on arrival your stay and everything is all arranged, everything is sorted?
Yeah, actually, that's a good thing about Facebook, right? Almost everything is sorted. They've taken care of almost everything. There are a couple of things, of course. There's a lot of paperwork that gets involved when
Of
you are
course.
switching countries. So that's
Right.
something that you need to take care of. That's
Right.
not something that they can do for you. But other than that, yeah, it's been breezy to say the least. But it's still a lot of work. It easily
Yeah.
takes up a month. Like I
But
didn't notice how.
are you getting those goosebumps like new country, new environment, new
Yeah,
culture,
I
food?
yes,
For me, the
yes.
biggest problem is food. You know, you go to a new place, खाना कैसे arrange होगा?
खाना खुद ही बनाना पड़ेगा. There's no other way around. I think London still has a lot of Indian restaurants, so it
Right.
shouldn't be too big a problem. But then
Right.
again, yeah, I know cooking, so I think I'll manage. Let's see.
Awesome, awesome,
Yeah.
awesome. Great. So everybody who has joined us so far, we have Bhavul with us. Bhavul is moving to
Hello.
London to join Facebook London, as you guys can hear from our chit chat. What during this conversation, what we would be getting to know more about, we'll be getting to know more about Bhavul, of course, and then in addition to that, we would also talk about his journey to Facebook London as a machine learning engineer. Machine learning, do we call them machine learning scientists or machine learning engineers?
So I think the technical term would be machine learning engineer, or the official term for that Facebook uses is software engineer for ML. So that's what they call it. But honestly, there's just a lot of variance now in the industry. There's data science engineer, there's machine learning engineer, there's AI engineer, there's
Right.
software engineer for ML. All of them kind
Right.
of mean the same thing. There's data scientist, there's research scientist, right? So in my
Right.
previous company, I was called research scientist, and I'm going to be doing the same sort of work essentially.
Right, right. I think the only title that is scientist is kept for data scientist, which makes it a bit cool, you know.
I know.
I wish
I
they
think-
had machine learning scientists as well. Yeah.
Yeah. So I think outside, I'm not, although some startups are using scientist terms to hire anybody who does ML. Usually, these FANG companies or any big company giants, they reserve the scientist terms only for those who have a PhD. So I've not done my
Oh.
PhD, so I can't apply for a scientist position. Even if the
Right.
work is same, it's gonna be reserved for those who have a PhD under the name. Yeah.
Right. I'm familiar with this particular terminology for Volvo, because I think Volvo follows the exact same thing.
Yeah.
Even if you have done your masters, you can only be a data analyst or a software engineer, but the scientist term is only reserved when you have a PhD in the topic. So pretty
Right,
interesting.
right.
Pretty interesting.
Yeah.
But you have also been a data scientist, right?
Yeah.
How different is it? Is it significantly different? Is it exactly the same?
No, it's kind of the same. So it kind of depends. Honestly, company to company, it differs. Even now, although things have changed and streamlined quite a bit since like I started with my ML career, but even now, I think it depends a lot from company to company. So you could be given a title of research scientist, but then a work might involve mostly data analysis. So that
You're
can
right.
still happen, and the other way around could also be true, right? You could be called a software engineer, forget about having any ML thing in your position, but then you might
Right.
be working on some cool ML stuff. So it
Hmm.
comes down to company to company. I think job description is where you get to know about what you're gonna be dealing with.
Amazing, amazing, amazing. And we'll talk all about that. But first of all, I mean, I would want to know more about Bhavul, who you are, where do
Yeah.
you come from. So where are you from, Bhavul? Where are you staying right now?
Yeah, so I'm in Delhi. I'm from Delhi only. Delhi is my
Okay.
hometown. I've been brought up here only, and then I moved to Goa. I studied there. I studied in BITS Pilani Goa
Hmm.
campus for 5 years. I did my
Hmm.
computer science bachelor's there and master's in mathematics.
Why Goa?
So
Why not BITS Pilani, the main campus?
no, I Goa is just better. Also, I did not score high enough, honestly, to get Pilani campus either. So I was like,
We were just
fine,
talking
Goa
to
is good.
Yeah, we
Yeah,
were just talking to Mohit last week, right? And Mohit said,
yeah.
"I just wanted to go to Goa because I mean, Goa,
Yeah.
it would be so much fun."
I think if you send anybody to Goa after a year,
Yeah,
they would choose Goa over other campuses. So it's true. It's true.
I'm pretty sure.
Even if somebody was initially planning for Pilani, Goa
Yeah.
does have that sort of a vibe to it. Yeah.
Right, 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 right. I mean,
Yeah.
the work and play balanced because I
Yes.
doubt the work and play will be balanced in Pilani or Kharagpur or Kanpur or any of those
True.
cities for matter.
Yeah,
Right.
can't really say because I've not been there, but I love Goa. If I wish there were big or any good companies in Goa, I would have stayed in Goa. It's just as simple as
Completely
that.
agreed. Completely agreed. I was talking to this design firm a couple of years back. They were based
Yeah.
out of Goa, and I think some of the best creative work is done in Goa for unknown reasons. Uh, Amazing. So,
Uh,
BITS Pilani, computer science.
yeah.
Um, was that your first interaction with computers, or have you been coding for long?
No, no. So my first interaction with computers would have been back in sixth or seventh standard. But that was not coding. I think I started coding in ninth standard ish when again, just like Mohit, I think I was introduced to HTML and these sort of things, web designing sort of thing. But from
Hmm.
sixth standard itself, I did a lot of graphic designing. So I worked with a lot of Photoshop
Wow.
during that time, and I
Wow.
designed a bunch of things for some websites back then.
Hmm.
uh, then it went on to front end. In the college, I did some front end work, some designing work, just kind of carrying on to whatever I had learned during school time. But my proper coding experience started in 11th standard when C++ was taught in my school.
Hmm.
So that's where I was fascinated. Honestly, I was very fascinated by a simple for loop, what it could do, and what all we could accomplish by writing a simple program, right?
Right.
And that fascination has been there for each and every sort of subfield in computer science. So it was always a known for me that I'm gonna take computer science up. So I was sure from then on that if I'm going into a college, it doesn't matter which college it is, but I want to make sure it's computer science. That
Right.
I was pretty sure of. And then yeah, it kept on going. I tried almost every sort of thing, right? So graphic designing front end, I've done a lot of back end work as well during college, after college. But machine learning was I was introduced to machine learning in my second year in the summer vacations. I tried to do this course that was becoming very popular by Andrew Ng
Oh.
on Coursera, the
Hmm.
original OG machine learning course.
Right.
uh, Went through that. I was again completely fascinated by what machine learning can do and what it is basically. And
Right.
then that caught my eye. I tried to take up from then on. I tried to take up every single course that my university offered related to machine learning. I remember continuously knocking on the door of professors that I want to do some project with them. I even stayed back the next following summers in the campus alone just to work with a professor on a research problem. So that
Wow.
was where the entire machine learning journey started for me. I worked on support vector machines, which are not so popular nowadays. It's a machine learning algorithm, one type of algorithm. And some papers came out of that, but that's where my journey started, and it's just been going on from then on. But yeah, after that, after college, I went into direct eye. There I joined as a software developer. So
Right.
initially I was just working on backend stuff.
Right.
Slowly I transitioned into some machine learning projects, and then since then it's just been machine learning.
Machine learning, data science, machine learning.
Yes, data science.
Amazing. Amazing. So we have just one quick question that I would want to answer. Joyjeet Pal. So Joyjeet, what we are talking about right now is Bhabul's journey. Bhabul's journey to Facebook London as a machine learning engineer, and what sort of helped him in that journey. What worked, what did not work. Make sure that we can learn from maybe any mistakes that he has made, and make sure that we are able to avoid that, and we are able to help more people move in that direction if they want to. Right. We'll also
Right.
come to that question, should they or should they not? We'll also come to that question on when is it okay to choose machine learning, when is it not okay to choose machine learning. Great. Awesome. So Facebook London, right? I mean,
Yeah.
before Facebook London, you were working at Zapper. Zapper.
Yeah.
What does Zapper do?
So Zapper is a company in a media advertising space. Their primary source of revenue is through advertising. They help advertising agencies and advertising partners to kind of build a strategy as to for offline advertising where they should be advertising, right? Which channels would give them the best yield of reaching out to the target audience while still being able to optimize their cost, right? So that's their primary source of revenue. It works. The entire backbone is a lot of data, right? So
Right.
they have some patented signal processing tech through which they're able to identify like who is watching which TV program at a given time. Okay, so now this is obviously integrated into some applications and platforms, and it happens via consent form. But whoever signs up, we can obviously through this way in an anonymized manner get an idea of who is watching what sort of a serial or what sort of a TV show or what sort of a movie, and that sort of a data is quite helpful in then identifying which sort of an audience a particular advertising agency should cater to and which channel are they usually on a given time and date, right? So that's where the backbone is built up. Recently Zapper has been trying a lot of new things in voice domain, so voice and speech domain. So they're working on some new speech tech, and it's all in-house. The speech recognition to the chatbot building process, and we're trying to work on voice bot related technologies, wherein we try to work with certain clients and try to solve their problems of automating part of their customer center calls,
Amazing.
at least the more common use cases. So these are some of the things that Zapper is working on right now. And there are a few other projects that Zapper worked upon that I was when I was in Zapper. Now it's been a month. I miss Zapper quite a lot. It was an amazing place to work actually,
Right.
and it gave me
Right.
the opportunity to actually own up a lot of modules and work on all the cool machine learning stuff there.
Right. I mean, this actually brings me to a very interesting learning that I got just a couple of days back. Right.
Yeah.
Machine learning in itself does not have implications only towards fan companies. It has implications all around. For example, just a couple of days back, I'm a big time automotive fan. Right. I think most guys are. I can. So I was looking at this particular brand that is based out of Europe, and their entire car is designed by machine learning. So not a single person is involved, and they have brought down cost by 95%. So
Nice.
99%, sorry. So the cost to develop a hypercar usually is 500 million. Just because a machine is doing it and no human is involved, the cost to develop that car was just 5 million. 500
That's
million,
amazing.
5 million.
Yeah.
And
Yeah.
I think the implications of machine learning is very, very wide, right? It's
Yeah.
across the industries, and I think that is one of the biggest places for people to experiment, learn, and try.
That's
So
true.
among all of these opportunities, what made you choose Facebook? Because Facebook has been doing the same thing for a very long time, at least to the outside world.
No, yeah, that's true. So Facebook was always one of the dream places to be. They whether you believe it or not, they do work on certain very challenging problems. Like some of the problems that I'm particularly interested in, for example, is fake news detection. For example, right? That's a very crucial problem that we are all facing, especially if we have looked at our parents' WhatsApp groups. I think we've all seen these problems. So
Yeah.
problems like that, a problem like preserving integrity while still maintaining freedom over a social network, right? These are some of the things that I find particularly interesting. Facebook seemed like one such place where I get to work on these. I was even happier when I got to know that these teams are specifically placed in London itself. There are a bunch of other teams as well in London, but this was something that attracted me quite a lot. Although it was not a outbound scenario, I was reached out by a HR from Facebook, and that's where it all started. Like that got me flowing, got the thought flowing that hey, maybe this would be a great idea and let's try it out. And
Right.
then this entire thought process began, and I gave it all my time that was required. Yeah.
How was that preparation? I mean, for example, let's say when the HR reached out to you, did you immediately interview, or did you take some time off for preparing first?
No, I took a lot of time. So I think this is where my journey would differ from quite a lot of folks. My entire interview process lasted over 6 months, and that would be a
Wow.
surprise to almost everyone, I guess. The reason being, even though this is a machine learning role, Facebook as such, even though it's a tech giant, right, it tries to work in very small teams, like small startups of their own.
Right.
Okay, so
Right.
they still try to retain that sort of a culture within them, that you should be bold, you should try to move fast, and you should try to own as much as you can and build things completely, right? So it kind of
Right.
gives you that uh, all the positives of having a tech giant, as well as also all the kind of ownership and freedom that you need in a startup, right? uh, Now with Facebook, what was happening is, even though it's a machine learning role, it's very unlike all the other companies that will take machine learning rounds. So usually other companies will end up asking you, taking 2 or 3 technical rounds. All of them will be machine learning based. So if you've been working in the ML space, you need a few revisions and you can kind of crack them. Okay, and you can crack most of those rounds if you've been working in machine learning or if you've studied well enough. Um, in Facebook, it was not that way. So in Facebook, it was primarily a software engineering interview with a one ML round in between. So what that meant was that I had to kind of relearn everything that I had learned back in college time.
Go back to the basics.
All the basics, right? Data structure algorithm, I had completely forgotten about all of that. So
Right.
so it was a lot of relearning. It was also a lot of new learnings, right? System design is something that I got to work on here or there during my first job, a little bit in Zapper as well. But again, I had not worked at the scale of Facebook. Like I had never built a system which would scale for, say, 10 million users or 100 million users, right? I got to work on that in Zapper at a particular time where I got to think about that. But usually, software engineers would get to do that more often than a person who's working in the ML space.
Right.
Uh, so that was something that had not occurred so many times that it had become natural to me. So these were things that I had to learn. So I took my own comfortable time. One lesson that I would want everyone to take from here is that I personally used to feel very anxious that hey, I should probably not ask for more than like 2 weeks of time or 3 weeks of time from the HR, but it's
Right.
completely fine. I through my preparation, one day I was reading some blog where a particular guy, some lead engineer, had basically broken down how much it costs to a company to hire a person or reject a person, right? Any candidate that gets rejected, a company loses close to $5,000 on them.
Wow.
And that's a huge cost to a company, right?
Yeah.
So if they would be more happy if you take your own time and prepare well. and then
Right.
appear for the interview, because they're going to lose more than you would actually
Right.
from a business, right? So yeah, so that's what I can talk more in details as to what rounds were there, and how much time I took for each of them. But yeah, I took several time. Yeah.
Yeah, we'll come to that. We'll just come to that, Bhavul. I would want to maybe break down a bit of that last component that you shared. It is the economics of hiring, because, for example, we talk about how much do these companies pay and the kind
Right.
of crazy pay scales they have. And in the end, it's these engineers who are interviewing you, right? So
Yeah.
their hour has a cost. If they talk
Yes.
to 5 people, they would want to
Yes.
hire those 5 people, right? If they are unable to hire four, those 5 hours that have gone in hiring that one person become a cost. So
Right.
if any, I mean, I think what Bhavul also put together very well is take as much time as you need, because the companies also want you to do your best and hopefully come on board and work with them, right? No company is
Right.
trying to reject you. We're all trying to do our best to make you extremely productive, extremely good, and work together. Um, can you, before we go to the interview pattern, can you give us a quick overview of your preparation plan? What was that six
Right.
months preparation plan? Where all did you spend most of your time?
Okay, so my initial plan was just 2 months long. Not, it was not supposed to go 6 months, but this is a common problem that I think software engineers deal with. That spillovers happen. So
Yeah.
now my initial plan was that I need to do well in all of these rounds. Right? There was primarily a coding round. There were a few coding rounds, which were data structures and algorithms. There was a system design round. There was an ML system design round, which is not the like the usual ML rounds that startups take. Um, so it had to be completely new sort of learning as to how you need to structure your answers for any sort of question that appears in this. And again, then there was behavioral, for which there isn't too much of prep needed, but I can talk about that later, right? So these were the 4 rounds. I was primarily focusing most of my time for the preparation on the first three.
Okay.
And for coding, I think my initial plan was that, okay, I need to. I was scared of coding, honestly. So I've not been that guy who used to always do well in data structure algorithm. I've been a good problem solver. If you give me a good problem, software to build, an application to build, I'll happily do that. Okay, and
Right.
and it's not like I'll write very bad code or anything like that. But somehow, just this idea, like if we go 1 year before this, and if we were having this conversation, I would not feel very excited about solving a DSA problem. And the
Got it.
reason for that was simple, that it was more like a puzzle, and I did not see it impacting anybody out there other than me. Of course, it could impact me, but there was no social impact to it. And
Right.
that somehow used to keep me from away from it unless there's a need. But here there
Got
was
it.
a need. There was a big need. So
Right.
at this point, I try to prepare a plan. There was a book named Cracking the Coding Interview. So that
Right.
was my first part, that I need to go through that book completely. Then I started going through one of these platforms. So I chose Lead Code, and I went through. I solved about 150 questions before I interviewed for my first round. Um, and yeah, that was my main plan for coding. That after that it'll be Lead Code. I can talk a little more in detail, but let me cover the breadth first, probably.
Sure. Sure.
Then for system design, again, since I was more new to this, with only few technology stacks that I've used here or there at various places, I started from the basics. Again, there's a course on educative grokking the system design interview. So that was the starting point for me. I also read a bit of there's this excellent book. If somebody has the time and bandwidth, I would highly recommend reading Designing Data Intensive Applications, Martin Kleppman. So again, a highly recommended book. If you got the time, it will build your thinking about scalability and about building these data intensive systems that which are having millions of billions of users, right? And then those were the two primers, right? After that, a lot of knowledge I received from YouTube itself. So there's this guy, Hussein Nasser, on YouTube. He has a channel
Okay.
on backend engineering. He has a lot of videos, I think hundreds of videos on backend engineering. And he has covered almost all kinds of technologies and the comparisons. So a lot of insightful content you will get from there. That okay, if you get to know that there are message queues such as you can use Kafka, you can use Redis as a message queue, you can use um, I'm forgetting the third one. But if you have three different message queues now, as a newbie, you might not know which one's the better choice at which time. So there were some insightful videos on this guy's channel where you'll get to know these kind of stuff. So that was
Akash
there.
has, sorry to interrupt. Akash Galab has this question. I think you mentioned a book for system design. What was that book? I'll just type it in
So
comments so that they have it.
the book's name is Designing Data Intensive Applications by Martin Kleppman. If you just write designing data intensive applications, I think you'll Google will like direct you to the book. It's an excellent book. I think if you've got a few months on your wrist, definitely go through that book. It'll develop the perspective and thinking about the right sort of thinking about system design.
Awesome.
The YouTube channel as well. It's Hussein Nasser.
Hussein Nasser. Great. Awesome. Sorry for interrupting. Please continue.
No problem. So Hussein Nasser was one. There are a lot of YouTube. There are a lot of playlists on system design as well on YouTube. If you just search system design playlist, you'll get through a lot of them. I remember Code Karle is one channel. Gaurav Sen is one channel. There were a couple of more channels, I guess. All of them are good. If you're somebody new, what you want to get to know initially is a lot of breadth, right? But one very important point is that there needs to be feedback loops when you're learning. So you cannot learn in this way where you go through a video and then try to understand what they said. I used to look at the problem that they're solving, pause the video, make the solution, and then go through the video. There have been a lot of times where I designed a very terrible solution. Okay, I've spoken to my close friends on a telephone saying, "Dude, I'm gonna fail this system design interview and I'm not gonna do well at all because I just suck at it." And then but it improves, right? With every single video, every single try that you do, you will improve and you will see that improvement. And either you're doing mock interviews or you're doing this sort of a feedback loop mechanism, it will help you know that as time processes, as you've gone through say 20 to 30 problems, you will see a definite improvement compared to the design that you'd built on your first few problems. So that was my...
Sorry, have you had a chance to look at interview bit system design questions?
I haven't. I do recommend interview bit. Somehow I just didn't go to that website, but I love that website. I had checked it out few years back. I've not checked it out recently yet though.
So the
I think
system design question, why I brought it up is because the format in which we give system design question is very much the same. You have the question, and then when you click on next, it would ask you, now you think about it. Okay. And then when you have given it a time, then you click on next, and then it will say, okay, did you think about what was your approach, and this is what we recommend. So it is sort of developed in the same fashion so that's why I brought it up. Yeah.
Oh, that's awesome. That's awesome. It should be that way. So that was a lesson as well. Another lesson was that so with system design or ML system design, both of them are open-ended questions, right? So your solution may not be the optimal solution, but it can still be the right solution. Okay. So and it can get you it can get you to be hired still. So the thing is that one aspect for system design is that you need to become okay with uncertainty. Like when you are coming up, when you're going for an interview, most likely in these fan companies, you're going to come up with a problem that you've never heard before with these open-ended problems. So you're not going to see the kind of problems that are mentioned online on these platforms. Most likely you will not. For system design, ML system design, it will be something new. Now, when you come across something new, you need to be prepared, and you should have gone through enough of such problems that you're okay with any new problem. And that's another thing that I learned, that which makes mock interviews very, very crucial for system design, I think. because you are experiencing that exact same nervousness, anxiety, whatever goes on in an interview, and you have to experience it so many times that you become okay. Now throw me a problem and I'll try to take a stab at it, right? It should not be that,
Right.
oh shit, I've not seen this problem at all. I don't know which pattern it belongs to and what should I do with it. You have to get from there to this other place where you get a problem and you're in that mode that okay, I'll take a stab at it and this is what I'm thinking about.
I have a question at this point. So, for example, let's say system design, is it specific to the level at which you were interviewing, or is that asked across all levels?
That's a very good question. So I think Facebook has levels in their hierarchies for software engineers. So from I'm not sure of their E3 levels and below, but E4 and onwards, which is categorized from senior engineers to tech lead to so on managerial positions. I think
Right.
system design stays as a constant round of interview. Some positions will even face two system design interviews. So that also
Okay.
happens.
Got it. Got it. Got it. Amazing. Awesome. And I had another question on the previous pointer that you mentioned, that you were preparing on lead code. Now, one of the challenges that I've heard from people who prepare on lead code or any open-ended platform is that you can solve a lot of problems and then you can still not cover everything, right? So what
Yes.
was your approach to make sure that you have some self-discipline to make sure that you cover a bit of everything and not just stick to something that you like, because that's what people end up doing, you know?
That again a very impressive question. So there are a few things that I want to talk about there. One, the lead code part. Second, the self-discipline part. Right. So let me go at lead code first.
Yeah.
My lead code started after I was done with cracking the coding interview book in its entirety. So, which meant that I have gone through each chapter, each sort of type of data structure and algorithm sort of problems on their own, right? So, initially, when you're just starting new, it's good that you take up a sort of problem like arrays problems or strings problem, and then you try to solve only a bunch of questions related to that sort of topic, right? But once I was done with the book, and I tried to code all the exercises also that were mentioned in the book for every chapter, as many as I could. Once I was done with all of that, that's when I moved to lead code, right? And that's where I moved to a completely random solving, because it will be random at the end, right? So you
Right.
will not know what sort of question you're gonna get, and
Right.
it's pretty important that you become okay with a new question appearing from a completely different topic. So that's where I started with lead code. Another thing that I tried on lead code was I used some extension to hide the difficulty level altogether. So
Okay.
so when I'm solving a lead code problem, I open the problem and my mind is not biased by seeing if it's an easy, medium, or hard problem, right? Because you will not know these things when you're actually appearing in the interview, right? So that was
Right.
another thing that I tried to do.
Right.
And that used to make me very happy when I used to solve a hard question in like 20 minutes or 15 minutes. That used to
And then
happen sometimes.
realize it's a hard problem.
Yeah, then realize it's a hard problem. So there are some extensions like that. If you just search for lead code in Chrome extension, I think you'll get through one of those
No, I
which
think if
hides the
somebody from LeetCode is listening, please, this is a very important feature feedback. You should build this feature so that people don't have to download extensions.
That's true. That's true.
All right.
But yeah, I did that. I also tried to. Initially, I was trying to do some there are some 100 top interview questions. I was trying to take a stab at that, but later I just purchased the premium account from LeetCode, and there were questions there which have seemed to appear on previous Facebook rounds. They were tagged with Facebook, so I tried to make it more focused because I was only targeting Facebook at the time.
Right.
So that also helps, I think, because one thing that I realized quite later on was Facebook. It seemed so. I'm not too sure again on this, but it just seemed that Facebook was not asking a lot of dynamic programming related questions as much
Okay.
as say some other companies do. So just doing slightly more focused way of solving DSA problems will help in such manner, right? If a company is focused towards a certain kinds of questions and not towards certain kinds of questions.
Got it. Got it.
Yeah.
Interesting. And maybe before we take up some questions, one last question that I have been waiting to ask the whole day before we get into this session. So machine learning is definitely a buzzword, right?
Yeah.
I mean, it is very safe to say that it is one of the top buzzwords in the tech industry, right? Everybody who talks about any new product, oh, we have applied machine learning, oh, we have AI. When is it okay to chase after machine learning, and when is it not okay to think about a career in machine learning?
All right. So honestly, I will be a very my opinion might be a little biased, right? Because I believe machine learning will be. I am sticking to this because I am fascinated by all the aspects of what all it can enable us to do in future, right? I believe that
Right.
it will get us in a couple of decades. It will be one of the primary factors which gets us to a future place where we are right now will seem very archaic,
Hmm.
right? So maybe children or children of ours will feel that you lived in some very old age times. So
Right.
that's where I think it can get us, right? And that's why I think it's going to become an important aspect of software engineering in any way, right?
Hmm.
Regardless of whether you chase after it or not. Now, whether I can talk a little bit about where the industry is right now and what you get to do if you are getting into machine learning and what you don't get to do, and what kind of myths are there, and how I can try busting a few of those, right? So
Right.
um, now as a machine learning engineer or research scientist or data scientist, you should understand that you will the good part is that you're going to mostly work on some cool problem. Okay. The reason is that people are going to come, a business is going to take up a problem with machine learning only when they are kind of sure that it can't be solved via plain old engineering. Okay.
Hmm. Hmm.
If they are doing the other way around, I don't agree that's a great way to do it actually right now. And
Okay.
this is not just me, even Google says so, that when you're starting with a product, start with engineering. So engineering
Hmm.
will get you 50% to where machine learning can get you with
Hmm.
some very basic rules, right? So once you have inherently you will get to work with very cool problems which will make you think that, hey, this is something complex, but this is something that can be achieved only by machine learning at this point, and
Hmm.
that inherently has a cool factor of its own, right? uh, but how in reality any problem with machine learning is built on data, so it's not built
Hmm.
on you using your own logic and writing out the rules, right? Usually with a problem, like for example any DSA problem, you are thinking about the logic, right? You're not writing a program which will write the code for the DSA problem. With
Hmm.
machine learning, what you're doing is you're relying upon data. There are a few algorithms. There are there can be few tweaking around these algorithms,
Hmm.
but there are a bunch of algorithms that work. And what you have to work on is building and having good data with so that these algorithms can do the job and solve your problem, right?
Right.
So a
Right.
lot of work for a data scientist or a machine learning engineer is about building this data properly, right? So so any new problem you get, maybe
Hmm.
5% of your work will go into initial research of what people have done or how people have tackled this problem,
Hmm.
after which you will be spending 50-55% of your work just building the data correctly. And by building
Hmm.
the data, I mean getting the data, whether it by scraping, whether it's by writing your on your own or hiring agencies to do it for you, and then pre-processing the hell out of it, right? So you will write a bunch of scripts to kind of get it in the form so that these algorithms can learn properly from it.
Right.
And then
Right.
there's the cool part, which everyone thinks is cool and which every course also teaches you online, right? Most of the
Hmm.
courses, when they're teaching machine learning, are going to talk about these algorithms, that what
Hmm.
are these algorithms and how they can learn to do something, right? It
Right.
is the core aspect, but in your job, it's going to take up only 10 to 20% of your time. Okay,
Awesome.
so here's where you are trying to here's where you get to tweak around these algorithms, try to see which algorithm works, which doesn't work, which one will scale, which won't scale, and
Hmm.
just try a bunch of them. And it's an iterative process. So if again
Hmm.
you're the kind of person who doesn't like iterations, machine learning might not be the place for you, because machine learning, and why jobs are called scientists, is because it's based on science and not engineering. So there's this science aspect to it, that you try out something and it
Hmm.
may not work at all,
Hmm.
and then you're going to try again with something else. And there is
Right.
that aspect which, yeah, you don't usually get in engineering, right? I'm
Right.
not saying that either of them is less beautiful. I like both of them honestly quite a lot, but
You know
it's just
what is
I'm just yeah,
this is very closely reminding me of humans, like what how we talk
yeah,
about humans, that you only see the success and the fancy part, you do not see
right,
the failure and the years of hard work. So when you think about
exactly.
machine learning, it's exactly the same. There's a lot
Yes,
of
yes,
hard work, training training your machines and all of that, and people only look at the fancy part. Oh, you just did and money machine did everything. So
yeah,
pretty, I mean, I think that's what it makes it very, very, very interesting. Awesome.
right,
Okay,
right,
so
and
let's
yeah.
take some questions. I think. Sorry. Please go on.
No, no. So I was just saying that the last part of what you will be doing in your machine learning job is communication. So exactly this part, right? A lot of people in the industry still see machine learning as a fancy tech that you can try to apply and then it will do the job for you.
Right.
It's not that way. It's a very
Right.
iterative work, and because of that, a lot you need to be good at communication, specifically how are you promising things, because an engineering pipeline you can design the architecture once and then kind of plan ahead of time how many months or how many weeks or how many days it's going to take, because all of the tech is done and this is all deterministic, right? With machine learning it's not deterministic. So you have an idea that okay, if I prepare data like this and I use this algorithm, it should mostly work, and it may not work after one month, right? And then you
Right.
have to inform your stakeholders that hey, this did not work, but this is other algorithm which will work, because by then you've gotten to learn about it. So there's this iterative aspect for which your communication needs to change, and I think a lot of stakeholders also learn while they're working with machine learning that about its iterative nature. So a good part of being a machine learning engineer or scientist is being able to communicate these things with the stakeholders properly.
Amazing. Amazing. I have so many questions right now, but it's just like I know that we have people with us. We have a lot of viewers
Yeah,
right now who
yeah.
have questions. I'm so excited about this topic. I just want to keep talking about it. Okay, so we'll keep going in sequence. We'll start off with Sambut. Sambut has a question that says, "What's the difference between AI engineer and ML engineer? Is there a difference?"
Short answer, not so much. And I would say look into the JD. There are a lot of different terms that are being used to describe an ML engineer. Job description or talking to the HR will tell you exactly what the job will entail.
Is it safe to say that a lot of times these titles are used interchangeably?
Yes, 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 yes. It completely depends on which term looks fancy to a particular company, I feel.
Yeah,
So,
yeah. If it's a startup that's trying to attract a lot of people, it might just say AI engineer.
yeah, it could even say scientist of some sort.
Pretty amazing. Okay, so this is a very, very good question. I've been waiting to take this up. Can you explain any DSA problems, any DSA topics that are not needed in data science at all?
Not needed. So here's the thing, right? If you're appearing for most of the companies, right? I'm pretty sure that these tech giants will take data structures and algorithm rounds. If you're appearing for an ML role, even if you have a PhD. But other than that, most of the companies will not. Or even if they do, they will have a very simple round. So because most of your work is not going to be centered around the kind of things that an back-end engineer or a front-end engineer would be doing. So the work in itself is quite different, right? There is some aspect of coding involved. Of course, you need to be a good coder, but
Right.
then DSA is something that on which not a lot of people test you, right? Most startups will not. Some will, but even they will be usually simple problems. So as long as you have some basic knowledge, you've done some top 50, 75 most asked questions in DSA, you'll be sorted, I think.
Awesome, awesome. But is it like if somebody has a very strong base in DSA, I think it doesn't hurt. It's always good.
No, no, it doesn't hurt at all. It helps only, right? Because I think one thing that I learned by solving a DSA is it does train your mind quite a lot.
Right.
Thinking
Intuition
logically.
building.
Yeah, intuition
Yeah.
building. Yes. Yeah.
Amazing, amazing. I think we have covered this to a certain extent, but if you could, like, for example, how many rounds did you have? How many
Yes.
were machine learning and how many were DSA and how many were
Yeah.
design?
Yeah. So there will be total 6 rounds that you will have usually. One would be a screening round initially, tech screening, which will be a DSA round. and this is an elimination round. So if you do well, you proceed to on-site rounds. If you don't, you're out. On-site, once you've proceeded to on-site, you will have all the rounds. There'll be 5 rounds there. There'll be 2 coding rounds again, which are again same DSA sort of rounds. Could be slightly harder problems. Then one system design round. General system design, any backend engineer usually is asked. One ML system design round, which I just realized that we have not covered too much upon. That if we get some time, I can cover a little bit of ground on that. And one behavioral round. So that's the rounds that you will have. I did have 2 extra rounds because for one of the round it did not go that well, but my communication was very well, and my method of approaching the problem was interesting to them, so they thought they should have a stab at it. So and that's what happened with me. I did not do well in actually couple of rounds, and then but they still felt that I was approaching it in a nice way. So sometimes that helps.
I think that again goes to prove that the companies are not trying to reject you. The companies are actually hoping that you make it through. Awesome. There are a couple of questions for Scalar, which maybe I'll just take up. So how does Scalar help to get into big data engineering positions in FANG companies? So Alok, Scalar is a program that helps you strengthen your entire DSA and strengthen your entire system design, right? So if you come into Scalar, you have you have a beginner, intermediate, and advanced batch, and they help you to brush up on your entire DSA, your advanced data structures, everything from dynamic programming, bits, arrays, manipulation. You will solve so many questions that you cannot think about, and then we'll also touch up a lot on system design. So that helps you make your resume and your interview experience a lot better. Okay, awesome. Just going through all of these questions.
This is such a good skill. You were talking to me and still reading all the questions. I just can't do that right now. It becomes so difficult. Kudos.
I think we have covered this. Maybe just a bit about what do you think got you the call?
Got me the caller. That's an interesting story. I'll try to shorten it. So I regularly try to keep myself updated with machine learning as a field, right? There's a lot of interesting stuff happening every day. And I usually do this via some newsletters. Now, one of the times there was this GPT-3. I don't know how many people in the audience have heard of it, but it was an algorithm that came out that did a lot of things at once without training it automatically, right? So, and it was done by OpenAI, the company headed by Elon Musk. So, they when it came out, before it got all the mainstream attention, I had basically just posted a simple post on LinkedIn about it, about my own thoughts about it. And somehow the next day I had received a message from the Facebook HR that are you interested in this sort of an opportunity. So I am not saying that it's completely a causation aspect there. It could just be two completely different things, right? But I do think that it could have been possible due to that. But yeah, that's when they reached out. I think the lesson there is that if you get to know about something, just share it on some social media. It might help you. You never know who's reading it.
Right. Just put yourself out there. The more you share, the more you talk to people, the more eyeballs you have. The only recollection of OpenAI that I have is that OpenAI came to play Dota. I think OpenAI had a Dota game against Dendy, one-on-one Pudge game. It was a pretty amazing game. So that is my only recollection of OpenAI. But pretty amazing, right? We have somebody from college. So Amar is in the second year of his college, and he knows some basic machine learning. What should be his pathway?
Great question, Amar. I'd suggest try to do as many projects as you can. The real experience of working on a machine learning project will make you learn about aspects other than just the algorithm aspect. So a lot of courses and materials online will teach you about algorithms, but in your machine learning job, you're going to deal with data processing a lot. You're going to deal with which should be the metrics, how should you deploy it, what is A/B experimentation, A/B testing, a bunch of things, right? That come up only when you have a project with you. So I would suggest try to work on some projects. It could just be simple as Kaggle competitions. Kaggle is a website where there are usually machine learning competitions. So they will propose a problem and a data set, and you just work on it, right? Or it could be something that you just think of on your own, right? And then try a stab at it. Open source it, do not open source it, sell it, that's on you. But I would say as much as possible get like practical experience. And if you want some resources on courses, if you still need to learn more, fast.ai is the platform I recommend the most. Deeplearning.ai is another website that has a lot of good courses now. So these are two platforms that'll give you a lot of content if you want to learn about different aspects of machine learning.
Awesome, awesome. We have another good question from Prabhat, which is like, if you look at the career growth, is there any pros and cons of ML versus software development?
Honestly, I do not believe it to be so. I think, yeah, forget about software engineer. You pick up any position, right? Everyone's making an impact, and it may not just be Facebook anywhere, right? When a product is coming together, there is a lot of engineering, a lot of product management, a lot of designing, a lot of machine learning that's going into it, a lot of QA work, testing work is going into it, right? And each of them are equally important, I feel. So I would suggest whatever technology excites you the most, try to follow that. Like listen what seems to be exciting. What if you and if you haven't, if you are at that place where you don't know what's exciting, just try out a bunch, right? Maybe in the course of next 6 months, pick something from machine learning, pick something from backend engineering, pick something from front end, right? Maybe pick up React here, pick up Kafka in backend, pick up trying to do some Kaggle competition on machine learning, and try all of them and see which seems most exciting to you, right? And then go ahead with that.
Right. Pretty amazing. I mean, I think we have another follow-up question from Weber. I think we discussed about Amar's career journey. What skills should a fresher have when they are approaching data science? Do data science jobs expect a lot from a fresher? Nowadays, I know software engineering expects a lot. Like even if you're a fresher in software engineering, you should have done a lot of work.
Yeah, so I think machine learning is always I don't think that a lot is expected from freshers. So what's expected is that you are willing to learn. As a fresher, I think that's the most important aspect, right? If you really want to learn to do this well, right? The passion aspect or the willing to learn and solve problems, that aspect is the first most critical thing for me to hire somebody. The other things would be that yeah, you need to have show some sort of interest, right, in some way on your resume. That will help a lot. There will be nowadays, I think a lot of companies have opened up taking freshers for machine learning positions. When I was sitting in my campus placements, there used to be only one, maybe couple of companies that will come for this. Most of the companies were not. In 2015, most of the companies were not hiring for machine learning roles out of college. Now there are a lot of companies, so there is a good chance that you get through. Just try to show a little bit of interest through projects or through the work you've done, through research papers, anything, right? If you've done some courses and some projects, I think that will show a good range of interest, and that can get you through. But they're going to ask you same machine learning algorithm related stuff only. They're not going to expect things like ML system design, for example, from a fresh. So it's going to be mostly knowledge based, and what algorithm would you use? What is how can you explain this algorithm? Can you explain something like decision trees, random forest? Why one is better in this situation? What would you use? Things like that.
Right. I think projects are very critical. Whether we talk about machine learning, whether we talk about software development, projects show that you like to build things. You don't just like to the theory aspect of it.
Right.
Now, Sambad has a very good question. Like, for example, how important is it to understand the maths behind the algorithms, and how deeply must we dig into the mathematical aspect?
That's an amazing.
Before we get into that, do you love maths?
I like maths. The aspects that are that are involved in machine learning, somehow those are my favorite aspects of math. I did do a
Right.
master's in mathematics from Bits Pilani while studying there, besides
Right.
computer science. So, but there are also some aspects of maths that I do not like so much. There is an entire field on abstract mathematics. Wasn't my cup of tea. But probability, statistics, and algebra and calculus. These are the four things that will come play a role somewhere in machine learning, right? And these are the things that will cover that you need to cover. Now there are very good places to go now. You can try to check out StatQuest as a YouTube channel. Can I type these somewhere? Or
Yeah, you
yeah,
can
maybe
post
I'll
a
type it. Yeah.
yeah, you can post a comment.
Yes. StatQuest, and then there's three blue, one brown, right? So you can try to cover a lot of math ground behind algorithms and behind what goes into machine learning just through these two channels to start with. If it feels interesting, try to go deeper into it. I feel a lot of software engineering ML jobs nowadays do not require so much of you delving into the mathematics of it. However, the
Right.
maths is always a bonus aspect. It will get you far. So if you like it, if you do not mind it, try to study it and understand it in more depth. Yeah.
Right. I think knowing how something works always helps. You can sort of, that's how you go towards the other side where you create libraries for others to use.
Exactly. Exactly. Yeah. Yeah.
Awesome. Okay. Kritika, I think Bhaul mentioned it took about 6 months for the entire preparation journey.
So 6 months, including all the interviews, were over in that as well. So
Okay.
not just the preparation. So
Right.
interviews were also placed in those 6 months.
Right. 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 How theoretical do we need to go for ML? I think we've already somewhat covered it. Uh, Thank you, Kangdas. We'll try to make more tutorials in Hindi. We'll try to have more conversations in Hindi. I'm really sorry for making it very English oriented. Um, can you maybe tell a bit about the importance of statistics in machine learning and the performance of ML models?
Statistics. I'm assuming this is regarding studying statistics to understand how models are working. For that aspect, yeah, there are essentially a lot of models work on probability and statistics. So you will come around with terms that are often found in statistics books or probability books. Normal distribution, p-values, null hypothesis. These are some things that become common when you're working in an ML job. uh, it's I would say at this point there's enough material on the internet that if you do not want to do a deep dive of a statistics course on its own, you don't need to. You can study the aspects that appear in machine learning, and they will be covered in one or the other platforms or courses, or even some medium articles itself.
Right, right, right. Awesome. Kritika says that Bhavul, you have an amazing Medium article. She has been following you for a very long time, and I think you've also written a bit about machine learning. So I'm just going to post that link here if somebody wants to, look at that. One last question, and then we can maybe call it a night. From Manoj, I think we can take the last few minutes to talk about these. What
Yeah.
did you exactly mean by ML system design? How to prepare for case-based ML questions like A/B testing, etc.,
Yes,
etc.
yes, yes. So thanks, Manoj, for asking the question. I wanted to
Yes.
cover this. So this is the aspect that will that makes fan companies ML positions different than rest of the companies. ML system design is where you will be asked a problem statement, just like system design. That hey, you will need to design, say something like Facebook feed or YouTube feed, right? The home screen. And but now you have to talk about this problem from an ML perspective. Okay, so now what usually is expected in this problem is to cover the entire ground of all that is utilized in ML. So first you will need to understand the problem. Like if they are talking about Facebook feed, okay, then what am I trying to optimize? I would want more engagement, for example, right? I would want more people to stay on the feed, right? So these this is more product level related discussion that you'll start with. You'll talk about the problem itself and what sort of metrics you will be following, right? Because any machine learning problem you're solving, you are gonna be looking into some metrics to see if this is going well or it's not going well. So metrics becomes a part of it. You need to discuss metrics. Then you go on to discussing about the data. So what data will be available to you? So you have to think about, okay, if I'm designing a Facebook feed, and my idea is that if a person logs in, I'm able to show relevant recommendation of posts, images, videos, etc. to the person. Then what data do I have available with me as a Facebook engineer that I can utilize for this? Okay, so you need to think about user profile data that will be available to you. Uh, uh, Maybe data about what day it is, what time it is it a holiday, right? A bunch of things about what sort of data is available to you. What sort of groups is this person in, what sort of friends does he have, what sort of topics has he liked, right? This becomes your data, so you have to think about what would be the data part, right? So you're not given any data set, you have to come up with what would be the features that you will be using in your machine learning problem here. Okay, and you come up with that feature set. This is called the feature engineering part. So we covered problem statement, metrics. Third is feature engineering. You try to then talk about, okay, if I have these features and this data and these metrics, what algorithm will I use? Okay, now when you're talking about the algorithm, it could be something simple as logistic regression. It could be like decision tree, random forest, XGBoost, neural networks, deep learning based any sort of architecture. And you have to be able to justify the decision. Just like in system design problems, you have to kind of justify your architectural decisions. Here you have to justify which metrics you're choosing, why these features, and why this algorithm, right? Will it scale for this problem? There are going to be 1 billion people using Facebook every day. These many calls happening to the feed. Will your algorithm be able to make enough predictions at runtime, right? So you talk about algorithm aspect, after which you talk a little bit about deployment aspect, right? So how are you going to deploy this? Is there going to be A/B testing used? What happens? What sort of debugging strategies would be there? What if something goes wrong? How will you debug it? Are your models interpretable in nature or not, right? So these are some sort of questions that you try to cover in the deployment aspect. That what if something goes wrong? How are you going to tackle it, right? So
Right.
When you're given a ML system design problem, you have to kind of cover ground on all of these topics one by one, go through each of them and go into a little bit of depth of each of them. And if an interviewer wants you to talk more about any particular topic, you need to talk more about that particular topic. But yeah, that's the idea. Time management becomes very crucial because each of these topics is can easily take up half an hour if you want to. So it and it's on you. The onus is on you to kind of strictly shortly cover a particular area and move it to another area and make sure that entire ground gets covered.
Understood. Understood. We have one last very quick question. How important is data engineering for FANG if applying for machine learning or data science role?
Yeah, so I think data engineering is important because data engineering, I feel at this point, overlaps quite a lot with what you learn in system design. So when you're dealing with the system design problems that would be asked as company at FANG companies, they're gonna ask you things which scale up to billions of users, and they are
Right.
usually going to ask you things uh, which are running on their product. So maybe a feature on Facebook or on YouTube or something like that. So in that case, there is already a billion user platform. So there is a lot of data. So when you're dealing with data engineering, a lot of the lessons there overlap with the system design part, I feel. So you can, I think it becomes pretty important.
Awesome. Great. Thank you so much for your time, Bhaval. I mean, everybody who is watching us right now across LinkedIn, YouTube, do let us know in the comments if you would like us to roll out a machine learning data science course. And if so, what would you like to see in that? And thank you so much for taking out time on a Friday evening and talking to us.
No problem. It's been a pleasure. It's been a pleasure. I also want to thank everyone who came here. This was my first live stream, I think, in life. So sorry if I fumbled here or there, but I
No,
guess it was
I think
helpful somewhat.
Yeah, it was very, very educational, and I'm pretty sure that all of us, everybody. Can we guys get a quick response? Did you guys find it helpful? I'm sure that if you guys can just say yes in the comments.
Also want to just tell out that I am writing some more blogs. They are still in drafts, but I'm gonna share in much more depth about each of these rounds and like how you can prepare with whatever resources I use, right? So there's like a huge Notion directory I have of all the links I used. I will be sharing those in the coming weeks. You can follow me on Twitter, LinkedIn, or Medium
Yeah.
if that's gonna help you.
Please do. I mean,
Thank you
please
so
do.
much. Yeah.
We'll comment down all the links to Bhaval's profiles so that you can very, very easily connect with him, follow him. If you guys want to hear from, if there is anyone you want us to interview in future, anyone you would like us to bring to the platform so that you can hear from them, please comment with their name, tag them, let them know that you want to hear from them, and we will do our best to get them on board. Awesome. Thank you so much, Bhaval. We have so many
Thank
people
you so
who
much,
have
Saurav.
had a great time. Amazing. Thank you so much, guys. See you again next Friday. Have a good night. I hope you guys can hear us. Can you guys just give us a yes in chat if I am audible?
Where are we supposed to read anything written? I don't even know that.
On the right hand side, there's comments.
Okay, comments. I see.
Awesome. Great. Anup, Srinivas, thank you so much, guys. Thank you so much for joining us on a Sunday evening. Happy Independence Day to everyone. Hope you guys had a really, really good time. You guys celebrated in your own unique ways. And really important day for all of us as a country, as a nation. Just wanted to borrow some time of today's evening from Ramit. Ramit is a celebrated data scientist researcher who has, whom we have been talking to help us figure out the intricacies of data science. And we thought, let's use this holiday, let's use this a bit of free time that all of us have to catch up on what makes data science so elusive, what makes it so exciting, why so many youngsters are just talking about data science, artificial intelligence, machine learning, why those buzzwords are so frequently seen in resumes, and how can people actually start exploring that domain, right? So just for everyone who's joined in, thank you so much once again. We have Ramit with us. Ramit, would you like to maybe introduce yourself, who you are, where do you come from?
Yeah, sure. Cool. So thank you everyone for joining. Happy Independence Day. And yeah, really grateful that people had an hour to take out on a holiday. I'm sorry for doing this on a Sunday. And yeah, really grateful for all your time. And thanks to Scalar and Saurabh for hosting me. Hopefully we can take some of your questions and answer some of the things that people have in mind. A little bit about me very quickly. So I'm Ramit. I finished undergrad just 3 years ago. Although 3 years ago feels like a long time. I've aged very quickly. But just 3 years ago, finished bachelor's from NSIT Delhi in computer engineering. Since the last 3 years, I've been working as a technical lead at Tower Research Capital. It's a high-frequency trading firm. And over these 3 years, I've also expanded some of the machine learning research I do. I think, like a lot of people here in this session, the whole era of machine learning, although started a long time ago, it started picking up more commonly in India, etc., over the last few years. And during that time, I was also getting interested in research, undergraduate thesis, things like that. And that's what led to me getting involved in machine learning, artificial intelligence. Over these 3 years, I guess I've been honored to have collaborations with several different universities, professors, and everything. And it's all led to a good number of research publications and output. And the whole idea behind this is, as a community, for India especially, to contribute to research. I think research has made a lot of progress abroad, but in India, although there is a huge demand in terms of understanding how we get into research, there's little to do in terms of how people are actually achieving it. And the goal of this session is hopefully to bridge that gap a little bit.
Right. Amazing. I mean, I would love to know all the juicy details about research and everything, but before we jump into that, maybe give us a quick walkthrough of what your introduction to machine learning was. What got you excited about this field?
Sure. So it's a rather funny story, and it's not the most inspiring story. Back when I was in my last year of undergrad at NSIT, me and my friends decided that we need to get a lot of marks. Okay, so we decided we were hungry for marks, and interestingly, I'm department rank 1 in NSIT, and the thesis had something to contribute towards to it. So I figured that doing any kind of research papers might be a good way. Like if we can publish our thesis, it might lead to more marks. So very selfish, useless agenda, nothing more than that. So we wrote a paper, and the thesis advisor suggested that let's publish it in a local conference in India, which is what most people do. Our group decided that why don't we try something a little more ambitious? Let's try one of these big international conferences. And the teacher initially discouraged us. We decided that there's no harm in trying. Let's just go with it. 2 months later, the paper got accepted with some great feedback saying that although it doesn't look like a research paper, because well, we had no experience about research papers, but they said the core ideas make sense. So we're happy to publish the paper. And this happened in ACL, top NLP conference. Once that happened, I figured that maybe this was just luck. I wasn't sure. In fact, the conference coincided with my first day at Tower Research. So, like any sane person, I decided that full-time employment matters more. I decided to skip the conference. But then part of me realized that, that's something incomplete. I would like to go on a free trip. So research papers involve free trips. You get to go to all these conferences and all of that, eat a lot of good food. So I figured, why not? So as within Tower Research, I was still connected with some of my college friends, and I think this is something for everyone. Although you can't reach out to professors and all immediately, your friends are still people who can help you out. So as friends, we continued publishing some papers in small workshops, not student tracks. When you start, you don't want to start very big. You can't directly compete with Google Brain and Stanford. So we decided, let's start easy, small. We published some work on very tiny applications like tweet classification for suicide intent. And as you attend these conferences, so I think the key idea is you need to start somewhere. Like a lot of people I see take a lot of time thinking about roadmaps, making plans, doing courses. All that's great, but you need to start somewhere. If you don't start, then you're wasting some time there. So after I began, we got a few papers published. Once we published a few papers, I finally got to attend ACL the next year. This was in Florence. And that's when you meet like tens of thousands of researchers, Google Brain, Stanford, DeepMind, everyone is there. And they're all willing to, talk to you, guide you. That happened, and so it was just luck in a way. The paper got accepted. We just friends did some stuff just for an undergraduate thesis. No advice, no guidance. We didn't even know what a research paper looks like. I spent, I think, nights looking at what other people have published to see, okay, let me copy this from them. Let me copy the presentation. Let me try to make a figure like they do. And today, if you go and see the papers I wrote 3 years ago, in 2018, to the papers now, they've grown in how they look, but the key idea stay the same. Where it's just what you pick up as you keep going. So I think advice for everyone here is don't worry before taking that first step. Just start. Right. Even if it's with your friends, don't have friends, just do it solo. It works out.
Right. I mean, I can already see that a lot of people in chat already resonate with the statement that you're making. For example, we have Ritvik who is saying that, hey, I get scared with the idea of doing research. How do I even start? Right? We will start taking a lot of these questions one by one. Maybe let's just start at the beginning, right? So you mentioned one very important piece that India, while there's a lot of demand and there's a lot of conversations, it does not have a very strong research platform as of today, right?
Yeah.
So when somebody is thinking about research and they actually want to make it something important, then they have to think about approaching universities outside India, right?
Yeah.
Or approaching research institutes outside India. How do they go about that?
Right. So I feel over time, the research culture has been improving. Universities like IIIT Delhi, Manipal, I think from all tiers, it's not a tier thing. I think a lot of people come to me and tell me that we're in tier 3, we can't even think of research papers. But I think times have changed to the place where people alone, you don't need a professor to publish a paper. I know so many people, including myself, where we did not know any professor who had any publishing background. But we decided that can try doing it on our own. So the worst case scenario, you don't get anyone at all. There are definitely options to do it on your own. But regardless, I think the best idea is to always try reaching out to people. At times, people worry that I have nothing on my resume, so I shouldn't reach out. Well, the one thing I've learned over these 3 years is, the answer is always going to be no if you never ask. So even if you don't ask professors, you should reach out to people who do or publish research papers. For example, in fact, more than 50% of the team that I have today in IIIT Delhi, Georgia Tech, they're all random people who message me on LinkedIn. I had no idea what they were. I've never met them in my life. And I have co-authored papers with them simply because they took the first step in saying, this is our resume, can you take a look at it? And in fact, that's how I started. So it goes back to 2017, 2018, when I decided I want to try looking at what research looks like. So I wrote a message, LinkedIn, like a generic template kind of message, edited it out, made it a little specific for every company, and sent that to over 100 people. Of those 100 people, I think 6 or 7 replied, and most of them replied, we don't have the time. 95 didn't even reply. But one person from IBM Research said that, why don't we have a chat? So out of 100, just one person gave me a chance to have a chat. And within 2 weeks, I was interning at their Delhi office. So the idea in terms of starting out is do things on your own, take those first steps. And if you don't know what those first steps are, try reaching out to people on LinkedIn. I think with how open things are now, you can just message anyone. In fact, feel free to message me, ask me questions, and I'm happy to answer those. In fact, as this exercise of what I'm starting with Scale Up, you'll see more content around how to get into AI, like more detailed steps. But I think the first step is always this, that you need to start. I think I see a few questions here from Mudit, Tolik, Ritvik, where even Anhat, where people wonder that, for research, you always need an absolutely fresh new idea. It's not true. It's okay if you repeat what other people have done. For example, a very simple thing. I think everyone has studied some problem in data science, like how do I everyone's done things like classifying an email as spam or not spam. Everyone's done that problem. But how do you publish a paper like that? So you don't need to improve performance. You don't need to do X, Y, Z. You just need to do some extra analysis. Why don't you do email classification for spam or not spam in Malayali, for example? That's not been done before. So it doesn't have to be the fanciest, trickiest mathematical idea. It can always be simple things like, why don't we use the power of India? So, a lot of research labs I work with in India, ShareChat is a good example of one of the new booming startups in India where the whole idea is around regional languages. So we've made progress. Like Google search works great in English. Have you tried Google search in Bengali? Have you tried it in Arabic? Maybe not, but how well does it work? So problems are many, and you need to start working with these problems to realize. If you start wondering, where do I start? It's difficult to start. But if you start with any random thing, you will find something to take it ahead.
So if we just oversimplify and summarize it, the first step is to get started. You can just think about the smallest or the most closest idea to you, right? It could be geography specific, it could be a cross-domain implementation of something that is already being done, right? Awesome. And for example, you have this idea, you've started reaching out to companies, you've started reaching out to people, right? Now, when you hear back, how should you frame your conversations? Because like you said, out of 100, only maybe 2 might reply, right? Arshit, we would have loved to converse in Hindi, but for example, a lot of our audience members might not be Hindi comfortable, right? So English makes it more easy. No other reason.
Archit, you should message me separately. I'll talk to you in Hindi. I can speak well enough Hindi, so I'll talk to you in Hindi soon.
Yeah. Awesome. So you have this great idea. You reached out to a lot of people. Like you said, out of 100, 1 might reply, right? Now you reached out to a lot of people. Somebody has replied. How do you make the most out of those conversations? How do you prepare for those conversations?
Yeah. So I think that's a great question. And I think the main idea in anything, this is not just about research, but even a full-time industry role, anything, applying for masters, doing JEE and applying for undergraduate college, you need to show that you bring value, right? You can't just claim that I bring value. I can't just say that I've made Google search, so when you hire me. You need to do something and show it. So in something like JEE, you need to get a certain rank to get there. Similarly, with research, you need to have something of your own. It doesn't need to be a research paper to start. If you have a research paper, that's great. That shows that you can independently take a problem and do everything. But why not do a project? So, everyone has projects on their resume, right? Try to find a project that's the closest to the company that you're applying to. For example, if you're doing Amazon, you want to apply to Amazon as an intern, why don't you message some people who work in Amazon saying that I'm working on a recommendation system for mobiles or fashion or anything like that. So in that case, the idea simply is have something to demonstrate. If you walk into a conversation without anything to back up your claims, it's not going to work. In fact, when I started out, I would make claims like, I want to do this and I can improve this neural network. But then people would say that, have you done it already? You won't know if you've not taken that challenge head on. So be company specific, don't be generic. Like you can't say the same thing you said to Amazon to also say, for example, Uber, right? It's difficult in some cases. If you've done something around work related to maps, tell Uber that I've worked on some maps recommendation, traffic forecasting, anything like that. And it makes the conversation easy for them. You're requesting to take someone else's time. So in that case, you need to make sure that it adds some kind of value to them rather than just saying, you can't just say something. And surprisingly, it's very surprising to me that people on LinkedIn, in fact, to me as well, I get messages for referrals, positions at research papers, things like that. And they just say that we want to do this. But there are 100 people who want to do this, including me. So what makes you different? And what makes you different is, some project, something tangible that you have to show.
Amazing. I mean, I think that was a very, very detailed insight. You have to bring something concrete with your idea that shows that you are actually invested in it, right? You're not waiting for us to give you an opportunity. You're not waiting for the institute to give you an opportunity. You've already started. And now with our help, you want to take it to the next level. So for reference, you can also watch Shark Tank, right? Like you go there, you already built some business. You are high probability of getting some funding. Amazing. Another very, very cliche question when it comes to data science machine learning. A lot of people claim to be doing data science machine learning when they are primarily maybe implementing an existing library or when they might be primarily using something that's already there as a plugin, right? How do we build that self-discipline when we are able to assess, okay, where do I stand? Capability-wise, am I actually doing something concrete?
Right. So I feel a lot of what people think, and it's a myth that will get busted over time. A lot of times people think that you need to change something mathematically to publish a paper or to get into research, but there's often production related stuff. In fact, that's, it goes with a question on the chat as well around academic research and industry research. Often things like industry research could be more focused on productionizing ML models. So in fact, in industry, very often we don't write our own algorithms. We don't change things. Often you would just implement stuff, import libraries, but there's a whole game around how to optimize these, what parameters are good, and writing production kind of pipeline. So I think it depends on what your interest is. Are you someone who wants to do more ML engineering, more ML ops, maybe more business for data science? Or do you want to be someone who's doing more groundbreaking research work? And the con with doing groundbreaking research work is you're going to hit into roadblocks more often. You'll try 10 ideas. And very recently, I was having this conversation with someone in Facebook research where they told me that in research, if you have 10 ideas and if more than 2 of those work, you're doing something wrong in terms of research. So the whole idea is, you're going to hit roadblocks, and there might be years before you come up with good ideas, or there might be certain cases where you do everything in 10 days. So an example, in fact, of that is, the tagline of this discussion, these award-winning papers. So the first award-winning paper I got, we finished that paper start to end with the idea, like idea conception to writing the paper, code, everything was done in 11 days, just because the first idea we got worked out. And then there have been papers which are, I've been working on since 2018 and they still haven't been published. So it's always a, thing on luck as well. Or even research is something which is like going into a dark alley, but doing ML engineering or things like that are more defined steps.
Right. I think because you just touched upon, a lot of these industry-related things that are happening can be built into research, right? We have this question from Rupert. If you can elaborate the difference between academic research and industry research.
Right. So I'd say it depends also organization to organization. So I won't name specific organizations, but there are certain places where Industry research focuses more on taking existing things and applying it. For example, there are a lot of startups where they would take something that Google has launched or DeepMind has launched, and then they try to build a product around it. Maybe something like text to speech, maybe something like self-driving vehicle. So a lot of companies would do groundbreaking research on that, and then there's a whole world in taking that to customers. For example, Grammarly is a good idea of it. Grammarly does both. They come up with new ideas and they launch it into their product slowly. But then they have a whole ecosystem built around a product that exists, marketing that to people, etc. So I'd say industry research is more around finding customers and creating value. It can't be a theoretical idea that is groundbreaking. For going even simpler words, I think when something like discovering Bohr's atomic model of all things, discovering that has a huge theoretical significance, does a lot of work for academia and is the building base for hundreds of things. But does it have an immediate thing that you can sell to someone or customers and make money out of immediately? Probably not. So academic research is more about building those foundational blocks, and industry research is more about taking it to customers and monetizing it. And often a bigger organization like Google, Uber, Amazon, they would have both. So an academic team that focuses on their long-term vision, that we want to improve Google search. So what kind of NLP problem should we solve? And then there's a more industry-oriented thing which says that, okay, let's take this small idea, release it to 5% of users using Google search, and let's see how it does. That's kind of where the division starts.
Awesome. Okay. I think we just have another question by Afla, which is, because you're already working and you might be doing other things, you are mentoring people, you are helping others who reach out on LinkedIn. How do you, I have just added that part, do you actively study new mathematical ideas too? I think he's referring to one of your papers, which is on time-aware LSTMs, leverage things like Riemannian manifolds. Was that something you knew already? If no, how did you proceed? And I would just want to maybe add a bit on how do you manage everything together?
Right. So to start with, on actively looking at new mathematical ideas, I think you have to keep up with academic research, like keeping up with industry. If new Python library comes up, maybe we all are not up to date with what new is coming up, but at some point pandas didn't exist, and soon enough we've caught on to that trend. Over the next years, we'll catch up to more libraries that keep coming up. It's difficult to keep up with all new research, and like everything, you can't keep up with all new shows, but you end up watching some of them, right? So focus on a subdomain in AI. I think one of the mistakes people make when they start is they don't fix a domain. I've seen people who will do something in computer vision where they're trying to identify hand recognized digits. Then they're trying to build their own Alexa. Like, people want to do everything, but when you start, you can't. You have to pick a certain point. So in my case, there are certain domains that I follow, like finance is one of them. And I read papers. I, in fact, have a few bots on Twitter that keep posting some of the new recent papers that come in. So whatever looks like a catchy title, I'll go through it. If it looks interesting, then I'll read all of it. And that's where your source of new ideas comes in. Second source of new ideas is people. So like anything normally, everyone on this would have watched a movie on their friend's recommendation, although you have no idea about the movie yourself. So it's kind of like that.
Understood.
And,
Understood. Sorry. No, so I was just saying, so a community also becomes a very important part. Make sure that you're plugged into a community that is very focused on data science, that ensures that you have the creative juices flowing, right? Okay. Now, from a journey perspective, right? You have your idea, you have started reaching out to people, you have already done some concrete work before even starting those conversations. How to pick those institutes that might be most excited about it, because it's always better if they can find a fitment. Like, right, for example, you mentioned if you're talking to Uber, if you can talk about map related things that you've done, it's more exciting for them, right? Is there a way that people can test their ideas and see, okay, this company or this research institute might be more relevant for me?
Yeah, I think a lot of it has to do with more around what your interests are. So it's kind of like saying, take something that's more relatable to people. It's kind of like saying, what kind of movie would you want to produce, or what kind of developer do you want to be, back end, front end, etc. So it depends. Like, are you more interested by natural language? Are you more interested in healthcare? Are you more interested in computer vision? At the end of the day, I feel if you're doing something that you're not interested in, even to get into a certain company, it might get tricky. So it's often best to see what you are interested in and there will be some kind of like you would have got idea for that from somewhere, right? Like if you got into finance, there'll be financial companies, Tower Research being one of them, where they might be interested in finance plus AI. So you kind of need to see what interests you. And like I think Nikhilesh mentions, how do you pick domains? So, and here the idea is there's so many exciting things. What do we do? So it's again a matter of, you look at everything for a little bit. You can't watch every show on Netflix. Well, some of you can even, but at times, you need to pick what do I look at first. An important thing to do is you need to pick something that also looks like it has an easy place to start. I've seen people start with things like reinforcement learning without having any background, without knowing what a neural network is. Then it gets tricky.
Okay.
You need to know what linear regression is before you get into neural networks. So start by looking at the very basic things. Don't think that, in fact, even with things like lead code, don't jump into the hard problems. It might sound exciting if you can finish a hard problem, but at times the basics are where you need to start. And when you're comfortable with them, you'll automatically find a path which becomes more interesting.
Awesome. Great. So we have the idea, we have created some research, we've started reaching out to people, everything is all sorted, right? What's next? Now, what separates a award-winning paper to just another paper, right? Where do you draw the line? Okay, these are the characteristics that you want.
Right. So I think the biggest thing is having a paper that produces value. I think, like very correctly Nikhilesh pointed out, people think that research papers have to be maths heavy. You need to come up with some new function. You have to solve some integral that's never been solved before. None of that. In fact, the first award-winning paper I had no novel maths in it. There was, in fact, not a very heavy mathematical background. It was just more around an application that creates value in the world. A paper's award-winning status, like an award-winning thing everywhere, is the impact that it can make. For example, maybe we've not used anything novel to detect suicide ideation, but have we come up with something that prevents even 5 suicides that are happening on Twitter? If it does, then it has created impact, and that's what makes it award-winning worthy. So it becomes important for people to realize that don't chase all the fancy things in papers. In fact, some of my papers might have really complicated maths, but you'll find some of them that don't have any maths at all. So it's not about maths or complexity. It's more about the impact that you'll try to create. If it's a problem that has already been solved, like at present, I think I've seen more than 1,000 papers on COVID-19 since it came out.
Right.
Most of them do the same thing. They do something like, is this tweet about COVID-19 or not? At that point, are you creating more value? Are you creating more impact? Probably not. So the idea is, let's try to create impact and value that will improve AI, improve some application in the world, rather than just chasing fancier concepts or more complicated looking maths.
Got it. I want to take the next question from Narendra S. Can you list out some institutions or group who are very active in ML research?
Sure. So I'll answer this for India specifically first, because I feel it's more uncommon to find these in India. I'd say all triple ITs that I've seen are very, very, very not just active. In fact, I was from NSIT, but there was no research culture there. So I reached out to Triple IT Delhi, and say 95 to 99% of all my papers are with Triple IT Delhi. Besides them being active, it's also very inclusive of an atmosphere. So you will reach out to someone who works at Triple IT Delhi, even some of the people I work with, you will 100% get a response. They will tell you, what can you do? In fact, a lot of these triple ITs, IITs have slightly higher bar at times, but triple ITs, for example, certain industrial labs, they have these intern recruitment cycles. In fact, I've been part of these like for 2 years now, where we'll release a Google form, you put in your interest, and you get a task. The task can be something as simple as building a sentiment classifier or something, and then they take interviews. So it's almost at the point like getting a software engineering internship. So all you need to do is keep in mind that these institutes are hiring, look at their websites, look at their research pages. There are hundreds of research labs in India now, hundreds. So if you're an undergraduate student, try looking at what is the research initiative in your college. If not, try finding it in other institutes, or if you have the time, why not create one in your own institute?
How does somebody go about creating a club or a lab of their own in their institute?
So I feel that if I had started research 1 year before an NSIT, not propelled by my greed for marks, then I felt I could have created such a group, because you need, again, it's the same thing. Why will people join your group? Why will people join your company? If they see there's a benefit, right? So if you publish a paper within your college, you're going to have college people come to you. Like when I cracked our research, people in college came to me, how do you crack our research? Before that, no one came and asked anything to me. So if you create some kind of value, some project, or if you do something like Google Summer of Code, in fact, Google Summer of Code also has ML research kind of projects now. So in fact, I think TensorFlow is one of them who has very ML heavy stuff for Google Summer of Code. So once you get some kind of achievement, it becomes easier to attract people. If not, a group of friends can always come up with it. Like it's like creating a finance society. Find people with like-minded interests, generate some value. If you don't generate value and you're just talking about it, maybe over time it will be.
Awesome. Sorry for that sidetrack.
No.
Okay, we have another question from Namrata, which is again on similar lines. How can we shortlist right publishers to submit papers, and how to customize the papers for them?
Okay, so great question, first of all. And I'd say it requires a lot of research. It took me more than a year to figure out where to go. And it depends on what your requirements are, to be honest. Like, I won't be like other people and tell you that you should only target the top conferences. They can be really tricky. I know people who've submitted papers to top, including myself, submitted papers to top conferences more than 10 times and it gets rejected for years because they have a crazy bar. And then there's some where, you get, it's a lower bar. It might not be the most popular conference, but it's still fine. So you need to decide are you willing to only settle for the topmost, or are you willing to start easy? So my recommendation for people who are starting would be to start with a student track, a workshop paper. I started with something known as a student track in a top conference, and that was restricted to undergraduate students. So you can imagine that I'm not competing at least with people in Google Brain and Stanford, right? But over time, the idea is if you want to create value, you should definitely be targeting only the top conferences. If I can post a link, I don't know if I can post. Can I post a link here?
Yes, you can send a link in private chat, and then the team will post it in comments.
Let me just do that. So I'm going to post a link of how this is a very standard conference ranking kind of rubric. It's what everyone uses. So it has something like a conference tiering between conference ranks like unranked, C, B, A star. A star papers are really, really difficult to get, but they hold the most value. So when you apply to big companies, they don't just look at how many papers you have. They look at how many A star papers you have. So idea is, like everything in life, the idea is not to chase quantity but quality. So make sure that you try to, if you don't go for the best conference, you try for one that has some value.
Understood. Great. I'm just going through the questions that have been posted here. While we have already spoken about it to a certain extent, I still want to take up the question by Soumya Dudeja, which is any prerequisites for getting into research? What should a freshman focus on in terms of academics and learning, studying, and aiming towards research?
Right. Okay. In terms of prerequisites, and this is also around tower research, so that later. Around prerequisites, I would say the first part would be having some basic maths background. That doesn't mean you need to know, complex calculus, but you should know what derivatives are. You should know probability. So I'd say class 11, 12th maths, you should know at least that much. And you should have some kind of computer science background. Very basic, but you need to know things like loops, if-else conditions. If you just start with that much, and you can import some basic libraries, and Python is a very good and easy way to start. You can do ML in other languages, but it might just be tricky. So some basic Python, some basic maths, and you can start looking at courses, and that's a good way to start. Talking about academics, again, if you can take more ML-focused courses, if you can take maths-heavy courses, that's great. And I would say in terms of courses online, I think there are many. There are courses like the famous Andrew NG course, which is more theoretical. But then there are also courses which are more about, I think one of them is on Coursera only, around building neural networks with PyTorch. Those are more hands-on. So focus on maths, computer science, and the rest will follow.
Awesome. We spoke about our local universities and which one are providing a much higher support. When you talk about foreign universities, you mentioned emailing them, right? But for example, is there any other alternative as well which makes it easier to reach out to foreign universities? the question by Ajay Mehta.
Right. No, great question. And it's something that used to be very, very, very difficult because emails, well, not everyone replies to emails. In fact, I have a huge pile of mail sitting in my inbox. I'm doing nothing about them. But what's changed is conferences now. So with COVID, not that it's the best thing for us, but one thing that's helped with COVID is things are virtual. So conferences happen virtually. Now that conferences happen virtually, you can reach out to professors in conferences. They're sitting there the whole day, honestly. They have a thing like Zoom sessions, or they have something called Gather Town. For those who don't know, you can Google what Gather Town is. If you've ever played any Pokemon game on Game Boy, your character roams around a world where it meets different Pokemon and people. So Gather Town is something like that. It's a animated world, and as soon as your character comes close to another character, your webcam's on, and you start a conversation like we're having right now. I've met more than 20 to 30 professors like this in virtual conferences where they're having their morning tea. I'm sitting here late at night, and we talk about common research interests. And this is how I met someone last year who's a professor in Germany. And we had this 5-minute conversation around suicide work. And next thing we know, 5 months later, me and her have published a paper, and we have more coming on the way. At this point, conferences are easy for people to attend because you can do it from your house. You don't have to travel. There's not a lot of money involved. Otherwise, you have to find funding, and you only get funding if you have papers, etc. But in fact, on my LinkedIn, I often post about conferences that I'm attending or presenting papers in. Very lately, these conferences have free registration. Most of them. Some of them might have something like $10 US, $20 US. But at times they're free. If they're free, you can talk to PhDs. And companies have their booths. Last week, I was at this conference called ACL virtually. I had a few of my co-authors who've just graduated. They managed to get interviews from Google Research just within 5 minutes because they were in that conference. So in short, if not emails, not Twitter, not LinkedIn, try looking out for conferences, at least while they are virtual.
Amazing. Awesome. So I think one of the key statements is also to just put your work out there, whether it's via conferences, whether it's via online communities, whether it's via social circles, just if nothing else, start your own YouTube channel and start talking about whatever you're doing. Right? I mean, I think in today's world, it's just so many channels exist where you can just go out and start sharing what you know. And the more you put out there, the easier you are making it to be found, for people to find you and reach out to you.
Definitely.
Awesome. I think given the junction that you are at, right, you're as a very senior engineer at Tower Research, and you're doing so much work on the research side as well, right? There's a very important question that Prajwal Mishra has asked. How do you go about an approval from your company to work alongside these institutes? Because I'm sure that all of these companies are also very secret about their work, because it's a lot of IPs, a lot of industry first. How do you go about that?
Right. So I think it depends company to company, not even company to company, but manager to manager. I've been very fortunate to, I'd say it's luck, I don't know what it is. I've been very fortunate to have managers who, given me their blessings since day one. It's not just do your research. They want to hear about my research. In Tower Research, I've presented my research papers. They want to hear about it. And they're also open to me using some of the ideas I've got in research within the company. But the trick here is you need to keep them separate. You don't mix the two. For example, Tower Research being a financial trading firm, I can't pick up what I've learned in Tower Research and put it in a research paper. That doesn't work. And that won't work with any company really. So there are certain domains where I know I can't publish based on discussions I've had with my employer. There are certain cases where I might need to show them a research paper before I publish it. But in most cases, if you can isolate the two, for example, I do research on suicide ideation detection. It has nothing to do with Tower Research. So it becomes easy to do those domains. The only crux here is if you want to manage both, you have to keep them mutually exclusive. And that just means you need to put in more time. So it becomes a matter of don't mix the two. If you can, don't mix the two. Otherwise, try finding a job where research itself is your own job.
Understood. No, that makes a lot of sense. I think the more exclusive they are, the least amount of conflict of interest, and the easier it is. We have a question from Srinivas. I think you've already touched about it. That you have some bots that help you with a lot of content, and then you pick and choose which one do you want to consume. But I think a lot of content consumption also goes into research, making sure that you're updated, making sure about what's happening. how do you keep track of everything that's happening in the industry, and how do you make sure that you are updated?
Right. So two answers to that. One is individually, what can you do? Like I mentioned, I think Twitter is a source I use, but there are a lot of other social media is what I'd say. Like you correctly mentioned, I think there's so many channels where people are putting out stuff. So you end up seeing it on YouTube, LinkedIn, Twitter. You follow the right people, which are just people who are publishing papers, and you get a sense individually. Now you see if it relates to what you're doing. Like, if it's something far off from what I do, I won't read the paper. But if it's something close, I'll read it. The second is through your community. So one is these conferences. Conferences are basically places where papers are presented. So you get ideas there. And then with your friends, right? So depends on what kind of friends you have. But I have certain groups where if a new paper comes in, we hear about it. If we would have a lot of institutes like IIIT Delhi has reading groups. So they take a certain time in the week, and if someone would present a paper and everyone else would talk about the ideas. So individually, you try to look at social channels, everything. As a group, you try to be around people who discuss similar ideas, whether it's research labs, industry conferences, and those people will teach you more and be your source of ideas.
Awesome, awesome. There's a question from Vipula Raute. It is something that I'm not able to maybe understand correctly, so I would just read it out. And then, how do you manage your ideas getting scooped?
Okay, controversial question, which I've not faced that often, thankfully.
Okay.
But it's a sad answer. The answer is you just need to be fast. It's as simple as that. It's like two companies have the same idea and both of them launch it. The one who goes faster usually gets the advantage, while you manage to keep your quality intact. You can't cut corners to get speed, but eventually it comes down to speed. There have been cases, in fact, where an idea we had, and it's not just with me, it's with a lot of people, where you get an idea after doing research for 2 years, you get an idea and think, oh, I've got something groundbreaking. You Google a little bit more and you see that's already been published a year ago. That things like this happen, and all you can do is make peace with it. It's a competitive industry, and you can't really do anything about it.
I think we are 7 billion people, might even be 8 right now. So, it's very hard to make sure that everything that comes to your mind, you are the first one to be thinking about it or doing something about it. Amazing. We have a question on how do you transit from a software engineering job to a research assistant, as both are in different domains. I think we have covered a bit on that, like, both can be done parallelly. Is there anything else that you want to maybe add on to that?
So I'd say the only thing I'd say if you don't know, then you try to do them parallelly. If you have even a 10% inclination towards one of them, then make your mind up. Like the longer you, in fact, this is the case with me also. I feel doing both is great, but at some point you need to pick one thing in your life. Like you need to have a concrete goal. So try picking one thing. If research is that thing from a software engineering kind of job, your best bet is that you already have half the skills, right? For research, you need to be able to code. You already have half the skills. Start one of those ML courses and follow pretty much the same steps. Like start reading research papers, put yourself out there, and don't do software engineering to build APIs, for example, or work on databases. Do software engineering maybe to deploy or put in an existing ML model. You'll start from there.
Awesome, awesome. Some institutes have good papers, but not traditional. Does quality of paper matters to reputation of or the reputation of the conference? I think, just to summarize from whatever I've understood so far, if you don't have a very high quality paper, you would not make it to a conference. So at all time, make sure that your paper is of the highest quality. It has a lot of information. It is creating a lot of impact. Anything else that you want to add to that, Ramesh?
Yeah, I'd go as far as saying that there are conferences where there's a lower bar. Like I think the ones you've mentioned, NeurIPS, AAAI, ICML. I go as far as saying that one AAAI NeurIPS ICML paper is better than 50 papers in some unknown conferences. One good thing is something that can add to your value. So the conference definitely matters. Like can't emphasize enough on it. Definitely matters, and if you can, you should only focus at the top level. The rankings I've shared, I think personally, this might come up as a little snobbish, but personally, anything below B, I don't think people will revert back to you. They'll think that they took an easy way out. They cut out on quality. So, and I myself have some of those lower rated papers. That's why I can say from experience, they've not helped me, as much as, and I put in time in them. Like, I put in, let's say I put 10 hours per paper and I got 20 papers, versus I put the same time in one paper. That one paper of higher quality always has brought me.
Amazing. Do you want to talk a bit about these rating systems and how papers get rated
Sure.
B, A plus, A star?
Sure. So, like we discussed earlier, the whole idea around a research paper being award winning is how much impact it makes, and impact can quantitatively be measured by something called citations, which basically means how many times has this work been referenced. So, kind of like even in a movie, how many times has this movie been watched? How many people paid to watch this movie? Similarly, how many people read this research paper? More importantly, how many people have used this research paper in their next research paper? So, like, I have two research papers published at the same time. Both are in the same conference. No difference at all.
Okay.
One of them has been cited 78 times. One of them has been cited 2 times. That automatically means that the one cited 78 times has had greater impact. And the impact at citations year on year is proportional to the rating. So these A-star conferences simply mean that your paper has a much higher chance of discovery by top people. In fact, I'll go as far as saying that once I got some of these A-star papers, I had recruiters from Google Research, Facebook Research, all of these places reach out to me only because I was associated with these papers, which are easily discoverable and easily cited, and follow this hierarchy of ratings.
Amazing. Awesome. I mean, that's pretty insightful. The more higher quality research you have, the more it gets used, the more it, the better rating it gets. Amazing. There's one quick question that I want to take up from Amir Siddiqui. Do you have to pay for your research paper to be published?
Again, controversial question, but at times, yes, you do need to. The reasons on why, or actually, let me rephrase. You don't have to pay for your paper to be published per se, unless it's like a shady conference. Those happen. Like, I've seen a few of them in India where they'll say we want 5,000, 10,000 to publish a paper. That's a red flag. But it happens indirectly, where conferences would say if you want to attend the conference, you have to pay some money. And that makes sense because hosting a conference also costs money, right? You're getting food, you're getting accommodation, all of that. So indirectly, you have to pay registration fees for conferences. But let's say you don't want to attend a conference. At times, you don't have to pay anything.
Got it. Namrata has a follow-up question on our recommendation of colleges that how can you go about approaching the IIIT research labs? Definitely, we spoke about emailing them, start cold calling, start putting your work out there. Anything else that you want to maybe add into that?
I'd say one of the mistakes people make is they reach out to professors, which is not a mistake, but you have to understand that they're busy people. What you can do is reach out to people who are interning there, for example. Those are the most, I would say, younger in their career, early in their career, so they'd have more time to help you out. Like, think of it like this: reaching out to your friend who does XYZ might be easier. So, for example, if you're interested in IIIT Delhi, reaching out to me is easier than reaching out to my professor. Reaching out to one of my interns is easier than reaching out to me. So you start with people who are younger; they have more time to help out.
Get cracking on LinkedIn, find the right people, connect with them, make some calls.
Networking is key. I think that's also everything around Scalar, right? So this whole concept of building like a virtual university, everything around networking, like ask people and people who are doing what you want, ask them, talk to them, they'll help you out.
And I think just to maybe plug in there, if anybody who's here who's looking to get started with data science, we have just launched an amazing data science program. You can head over to scalar.com. On the top, you'll see Scalar Data Science. Go ahead, click, look into it. You might find something valuable there, right? I'm always happy to chat and discuss if there's any follow-up question on that, right? Great. I'm just going through the last few questions. We don't have new questions coming in. I think we have done either a very good job at answering everything, or we have lost people's interest.
So we still have one from what I think we just got 1 minute ago. I think there's a huge. I don't know if there's a lag on your side or my side. Like I seem to have quite a few here. Not sure.
Okay. The last question that I have is from like a few minutes ago.
The last one I have is 7:49 only. So
Okay.
Anyway, I think let's just keep taking the ones we have.
Yeah. So for an undergraduate, is being able to implement research papers from scratch be considered better, or being able to come up with a new novel idea? See, I have to research kind of if I want to.
I would say that implementing is easier, but the value it might have would be lesser than being able to come up with novel ideas. So if you can come up with a novel idea and it works, 100 times better than implementing what someone has already done. But it's obviously much more difficult to come up with a new idea than just implement someone else's from there on.
Awesome. Manisha Reddy, is academic research a viable option for earning money when compared to a regular ML engineer job? I'm assuming that do you go full time into it?
Right. So it depends, first of all, from even country to country. I would say India, because it's on the I'd say it's on the curve where people are embracing research now. So I think it's becoming a place where there are jobs like research scientist, ML scientist. These jobs, in fact, as far as I know, pay a little bit more than the engineering kind of role. But if you're talking about academic research, maybe along, say, professors, postdocs, things like that, I feel that's a totally different career path. Then I'm not even aware of what the differences are. But very often, even people who are pursuing things like being a professor, they often get affiliated with industry research labs, etc. And eventually, I think that ends up paying more than just the traditional software engineer kind of job.
Maybe I'll just rephrase with this particular piece by saying that money is everywhere. You have to be really good at what you're doing, right? Even if you become a primarily research-driven research ML engineer, if you're really good at it, I'm pretty sure that there are a lot of people who are willing to pay a lot of money to just get your help and get your credentials and get you to look at whatever they are doing, right? So just focus on what you want to do. Focus on how do you become a master of that craft. And काबिलियत के पीछे भागो, पैसे के पीछे मत भागो. बाबा रणछोड़ दास का डायलॉग है. Is it advisable to put your unpublished research paper on arxiv.org to get initial feedback suggestion? How to avoid your paper getting plagiarized or scooped before publication?
Okay, good question. I personally don't put them on archive, but there's some different reasons around that. In general, I would say it's better to put it. It's like saying that although the paper is not published yet, we have made it public, so it reduces your probability of it getting scooped. It's kind of like saying कि ये movie hall में नहीं release हो रही, but ये YouTube पे डाल दिया हमने, something like that.
Right.
So at least no one can copy it completely. But then there are also times where you put it on archive and now you've given other people a basic idea to start from. They can modify it a little bit. I've seen cases where you put something on archive, people might take your base idea, change it a little bit, and publish their paper with better quality, more resources, whatever.
Interesting.
And once they do that, that reduces the impact of your paper because something better is already published. So it's a trade-off again. You can protect yourself, but it's like same thing. You put a short movie on YouTube, someone makes a blockbuster out of it, then your blockbuster is gone.
Amazing. I think very interesting topic. I think we recently came across a news around that, but that's a different conversation of all length altogether. Ravi Kiran Reddy, I think you've touched up on how to work with research labs outside India. Start reaching out to them, start reaching out to professors. Is there anything additional that you maybe want to add to that?
No, I'd say if you're in undergrad or if you're basically a student, there are these programs that India has. Like I think DadWise is one of them, which has like a collaboration between Indian and German government. So you can apply formally through these things and do that. If you don't want to do these or you're not a student, the best is through conferences. Go to conferences, network with people, meet them, reach out to them, put yourself out there. And it's a tricky thing, it's not very easy, especially because people abroad, their first question is, why should we get someone from India if we can get someone in our own country? So you need to show that you add a certain level of value beyond that.
Right. Just adding on to that same question by Siddharth Kumar, which country do you think is best for academic research?
It depends again. I'd say, US is great. I think it's at the cusp where it's very, very well celebrated. It's very promoted in terms of things like pay as well. I think certain research-based roles in US pay much more than the normal software engineering kind of track. But then there are other options. I'd say certain countries in Europe, say Germany, Switzerland, certain institutes, they have a lot of great exposure. Another benefit of Europe over US is that education is much cheaper. So if you're considering something like masters, it's in some cases like Denmark is free. Whereas if you go to the US, in some cases your masters can cost somewhere around a crore. So there's always that difference. India is making progress, but I don't think I'll go as far as saying that India is amongst the top just yet.
Not yet, but maybe hopefully very soon we'll be there.
Hopefully.
Okay, one last question from Anish Bose. How to improve research output by knowing whether to publish in a conference or journals?
Okay, I'm a little confused about what the question is exactly, but how to improve
I'm
research.
assuming it's more about how do you get more eyeballs on your paper? Whether do you post it, whether is it big enough to go to a conference, spending that much money, or should you just do journal? Like, how do you evaluate that?
Look, I think we can consider it something like difference between a conference and journal, something like that. So
Right.
I'd say conferences it depends on domain. So machine learning AI conferences are what is hot because you have quick sessions. No one has the time to read 100 pages. People want a 2-minute video that summarizes it, and that's what conferences do. Certain conferences you have a 1 minute, like just a minute kind of session. You have 1 minute, summarize your problem, and the next person is going to talk. So those are hot within machine learning, AI, etc. Journal, and the one drawback of conferences, I'd say, is conferences, you submit a paper, 3 months later, you're told is it accepted or not. That's it. It's a binary decision. With a journal, you submit a paper, you'll get feedback, and they'll tell you if you can do X, Y, Z, we will review it again. So it's like an ongoing process. But then for journals, you have to take in the marketing and publicity in your own hands. There's no conference, there's no event. So even if it's a great journal, you have to spread the word that look, this paper came out in this journal, etc. And journals at times can be more time consuming. But they are the preferred mode of publishing in anything outside computer science. So bio, chemistry, health, they do journals. Conferences are not comparable. But CS, ML, AI, conferences all the way, at least for now.
A completely noob question from somebody who does not belong to data science. If your work has cross-domain implication, let's say you are doing something in data science that also has implication in, let's say, medicals, right? Then does journal start making a lot more sense?
At times it does. In fact, I published recently, we had the option of publishing in a CSML kind of journal and an Oxford Journal of Medicine. That's kind of where you see what kind of impact do you want your paper to have. Would you rather have medical impact or would you rather have CS impact? In our case, we figured medical impact is more real world tangible. So we did that. And so interdisciplinary, you choose, you have a choice, right? You have hundreds of journals to choose from. You choose where it might fit best. In fact, publishing in the medical journal turned out to be well because if we published it in CS, maybe it would not have got a lot of coverage. It got published in a medical journal. Then we had Times of India and everyone reach out, maybe only because it was medical oriented. So you basically pick where you think, what adds the most value.
Right. No, makes a lot of sense. So that was just a bulb that went in my head. Awesome. We have another question coming in from Mohit. Which plagiarism tool do you use to check your paper?
So a funny thing, I've never used a plagiarism tool. I feel like, I'm very picky about what goes in the paper I write. Till a year ago, I used to not let my co-authors write. I used to be like, no, I have my own way of writing it, you're not writing it. Now I've got lazy, so we use something called Turnitin. So at times, some of the interns would use that tool. But in research papers, it's very, very easy to get caught. You should not be taking any risks. One wrong step and your reputation goes down the drain. So just avoid taking any kind of negative steps. In terms of plagiarism tools, if you're in a university, ask your professors. They have free software. Otherwise, I think these softwares cost a lot. If you're in a company, the company should have some kind of software.
Awesome. Great. I think we've answered all the questions. So from a journey perspective also, if I just try to walk through the entire journey, we spoke about how to get good ideas, right? You don't have to think of something groundbreaking. You can also think about implementations that are closer to you, that you don't see happening right now. You can start putting your content out there. You can start creating videos. You can start creating blogs, Medium. There are a lot of ways of just putting content out there that shows that you're passionate about what you're talking about, right? We can start reaching out to institutes by emailing them, by connecting with them over LinkedIn. Try finding people who are more approachable, interns, junior members of the team. They will be much more approachable. They'll be fast, easier to help you out. Network a lot. Make sure that now, in today's time when all conferences are happening online, make sure that you are attending a lot of them. Make sure that you're talking to a lot of people, and you're creating those networks that can help you out. Make sure that you're creating a lot of impact so that your paper, people want to read it, people want to derive some learning from there that can be helpful for them. All in all, if you're doing all of these, if you're checking all of these boxes, your paper has a very high probability of being an award-winning paper, right? And if you are still getting started, if you want a lot of help on data science, again, reach out to scalar.com. We have a data science program that can help you out. We would be very happy to chat. We would be very happy to. Ramit is helping us build that program very closely. He would also, in a way, be guiding you directly, indirectly. So, yeah. Anything else that you would want to maybe add to the concluding statement, Ramit?
No, nothing else. I think I'd say I'm very happy to use this platform that you have and reach out to more people. I think there's a lot of future in terms of improving the research and machine learning landscape in India. Over time, and in fact, right now, it's booming. So there's a lot of opportunity for even people who are employed already. It's not like you need to change your career trajectory or path or anything like that. It's something that's booming a lot. In fact, people often won't talk about things like compensation, but just based on what I'm seeing, there's more compensation on the MLAI side. So it's great to be on that place where we can make an impact and tell people how they can upskill themselves. It's a new booming thing. If it's something that interests you, get your hands on it. It might be beneficial for you in the future. So yeah, thank you for attending. Happy Independence Day, and please do something more fun than this after this.
Thank you so much, Ramit. Everybody have a good evening, and like Ramit said, have a very happy Independence Day. See you guys again next time. Thank you.